Well, good afternoon, everyone, and welcome to the 2021 North Dakota Ready Mix and Concrete Products Association virtual winter workshop. We are so happy that you're here. It is 1 o'clock, and we will start our program momentarily. We have a lot of information to cover here today, so we want to get right to it. For those of you that don't know, my name is Art Thompson. I am the director of the North Dakota Ready Mix and Concrete Products Association. I'm happy to be here today facilitating this event. A couple of things before we get started. All of our sessions are being recorded. They will be available for playback at a later date. Your PDH credits will be emailed hopefully on Friday, if not for the first part of next week. In order to receive credit for being here, you must remain logged on to get your certificate throughout each session. Questions can be typed into the chat window. We will do our best to answer questions after the presentation if time allows, but if not, we will follow up post-event. Each of you that are online today are eligible for a daily prize drawing. You must be logged on to for the complete session to be eligible. Winners will be chosen at random and announced on Friday. The more sessions you attend, the more opportunities you have to walk away with a door prize. Well, we believe we have a great agenda put together for the next 2 afternoons. One of the nice things to come out of the COVID pandemic and virtual events is that we're able to tap into a broad base of nationally renowned speakers that are willing to come and share their knowledge with us. And so I think you can see we have a great selection lined up for today and tomorrow. We're looking forward to hosting you and answering any questions you may have. Also, you won't want to miss out on our Gold Star Awards ceremony where we honor the best of the best in concrete projects over the past year. That is tomorrow from 3 to 4. It is a must-see event for anyone in our industry. Of course, virtual events and our conferences can't take place without the help of our sponsors. And so those companies that are listed on our screen are the platinum levels. If you know a representative from one of those companies, be sure to thank them for helping to make this virtual event possible. In addition to our platinum level sponsors, we do have several gold level sponsors as well. Again, at any level, we appreciate any contribution to our association and to help fund these learning opportunities for our members and for our industry partners. Thank you to our gold level sponsors. In addition to the gold level sponsors, we also received in-kind donations from Houston Engineering, KLJ, and Mountain Plains Engineering, providing their expertise in some of our judging of projects and things like that. So I want to thank our Gold Star Awards Committee from those 3 companies. Couldn't do it without you, and very much appreciate you taking time to support our organization. In addition, this broadcast is now now coming to you through our partnership that we have with North Dakota LTAP, and certainly Dustin and Dale and the whole crew at LTAP have done a fantastic job in lining up and making sure the technical and broadcast experience that we need for these events is done great. And so on behalf of myself and the board, I want to thank Dustin and Dale and the team at LTAP for all of your work that you've done in advance of this event and what you'll continue to do for us here over the next 2 afternoons. So thank you for that as well. Previously mentioned that anyone attending today's events will be put into a prize drawing. Traditionally at our in-person events, we solicit prize donations and we auction them off as a fundraising event for our scholarship program. Because we're virtual this year, each session attendee will be entered into a prize drawing on Friday. Again, the more sessions you attend increases your chance of winning a great prize. Please note that a portion of your event registration fees will be placed into our scholarship fund so we can continue that wonderful program that we do for university students. I want to thank the following companies for their gifts. So this is what you're vying for: Ash Grove Cement, Lafarge Wholesome, Boral Resources, GCC, Lehigh Hansen, and then our Ready Mix Association Board of Directors is doing the grand prize, which will be a $300 Visa gift certificate. So again, thank you for all of our sponsors and those that are providing technical assistance and in-kind donations. It's great to have partners that are willing to step up and help us host events like these. Okay, so we're going to move forward to our first topic. What we're going to talk about first is pavementdesigner.org, which is a free web-based concrete industry developed pavement design software program that's available to anyone who's designing roads, parking lots, intermodal facilities, and more. We are fortunate to be joined today by Eric Ferrebee. Eric is the Director of Technical Services for the American Concrete Pavement Association. He's responsible for research projects and was one of the leading developers of pavementdesigner.org. In this capacity, he's not only helped develop the software, but he's conducted several training sessions for it, and he continues to be on the team that constantly reviews and enhances the program. In addition to his work, Eric earned his bachelor's and master's degree in civil engineering from the University of Illinois at Urbana-Champaign. He also serves as the ACPA staff liaison with the Concrete Pavement Technology Center in Ames, Iowa. Eric has a wealth of knowledge and is a great presenter. Please welcome Eric Ferrebee.
Well, thank you, Art. Really excited to be here with you guys today and talk a little bit about pavementdesigner.org. Pavement design is something that I'm very passionate about. It's something that really has kind of gotten me into civil engineering. It's one of the reasons that I became a civil engineer, and it's one of the big reasons why I'm with the American Concrete Pavement Association, because I really enjoy concrete and cement-based pavement design. So today we're going to focus on pavementdesigner.org, which is an industry-based tool for designing concrete and cement-based pavements. And so this is a free tool developed by the concrete pavement industry for designing and building parking lots, city streets and local roads, intermodal type facilities. And we can do a lot of different things with Pavement Designer. So as I mentioned, pavementdesigner.org was made by the concrete pavement industry. So it was a partnership between the American Concrete Pavement Association, the National Ready Mix Concrete Association, the Portland Cement Association, as well as the RCC Pavement Council, trying to make a free and user-friendly tool for designing concrete and cement-based pavements. And so we can do, with this, we can do streets and local roads, like I mentioned, parking lots, intermodal industrial facilities, but we can also do a lot of things within that as well. So we can design for full-depth jointed plane concrete pavements, which would be our conventional concrete pavements that we see all the time. We can also design for continuously reinforced concrete pavements if we're designing something that's very heavily trafficked that may need some of that reinforcement. We can design for concrete overlays. We're seeing these become popular all over the country. So we can design using our existing infrastructure to take advantage of that as much as possible. We can also design using composite pavements. So anytime we're using a cement-based or stabilized substructure underneath, say an asphalt pavement, you can actually do that with Pavement Designer as well. But you can also do roller compacted concrete. You can design for cement modified soils or cement treated bases. You can also do full depth reclamation with Pavement Designer as well. So a lot of different things that you can do with Pavement Designer. And that's what makes it such a versatile tool and such a nice tool to have in your toolbox for designing concrete and cement-based pavements. Now, the concrete pavement industry really built this tool because we recognize that cities, consultants, counties, any type of engineer really needs a good, free, easy to access tool to design concrete and cement-based pavements. And we'll talk about one of the reasons why we recognize that need as we go through this presentation today. But there is really a need there for a good mechanistic-based solution for concrete pavement design. Now, we also developed this tool because we recognize that there's been a lot of turnover, not just at the DOT level, but at consultants and cities and counties as well. And we would really like to have a tool that professors can use at the college level to teach concrete pavement design, incorporate it into a pavements class to kind of get students exposed to how to design and design concrete pavements so that they're ready to go out into the field and start designing concrete pavements as well. Now, this tool is also a big benefit to the entire industry because it actually incorporates all of those different design methodologies that I talked about. You can design for joint and plain concrete pavements, continuous reinforced, RCC, really any type of concrete pavement that you want to design for, Pavement Designer can do. And that didn't exist before Pavement Designer. We had different tools that could do different parts, but Pavement Designer brings them all into one tool. So you can go to one place to design concrete pavements, and it's free. It's free, it's online, so you know that you're getting the best tool that's out there, most up-to-date, the most up-to-date software that exists. So making it free, giving everyone access to this full tool without having any restrictions on it is really something that was a goal when we were developing Pavement Designer. We released it in 2018, so it's fairly new, but the methodologies behind Pavement Designer are fairly old. These things have been around for quite some time, but they're still our best methodologies for designing cement and concrete-based pavements. So let's jump back to our map of what Pavement Designer kind of looks like in terms of what you can completely do with it. As I mentioned, you can do parking lots, streets and local roads, intermodal and industrial facilities. And in there, you can also do those overlays, RCC, continuous reinforced pavements, new composite pavements as well. But the reason why I spend a little bit more time on this map is to kind of reference what those existing methodologies are that have been incorporated into Pavement Designer. So if you're a pavement design geek like me and you want to know what's actually powering this design, is it something brand new or is it something that's been around for a while? This is a map that kind of shows you the existing design methodology that's been incorporated into Pavement Designer as our best practice for designing each of these types of facilities. So this map is actually available on Pavement Designer's resources section. I'll show you that as we go through the presentation today, but it's a good reference sheet to know what's actually powering the design of pavementdesigner.org. So we'll go through that a little bit as we go through here today. All right, so looking at our map, the first thing that we're going to talk about today is parking lot design. So how do we design a parking lot using pavementdesigner.org? So before we get to that, I always like to talk about what are the other ways that we can actually design a parking lot? What are the ways that you may have heard of or may be familiar with that kind of ring in your head before you think Pavement Designer, and how do they kind of compare? So the different ways that you can design a parking lot that exist that you may be familiar with are AASHTO 93, Street Pave, or ACI 330 design guides. So AASHTO 93 is more of a highway type design guide, and we'll talk about that when we go to streets and local roads, but it's not really something that trickles down well to parking lots. We also have Street Pave, which is, if you've ever heard of it, it's actually the predecessor for Pavement Designer, but that methodology has actually been incorporated into Pavement Designer as a part of our design process. So it's actually what's powering a lot of the designs in pavementdesigner.org. You notice that the PCA method was featured on that map in that previous slide. That's what was built into Street Pave, and then Street Pave was evolved into pavementdesigner.org, which is the free tool that now exists. But the thing that really is kind of made for parking lots besides Pavement Designer is these ACI 330 design guides that exist. So there was one released in 2008, and I believe they're still working on finalizing the current guide. But these design guides are fairly limited in what you can do. You're really designing based off of design tables. You can see some of what those design tables look like from the 2008 guide here. So you're fairly limited on what you can do. You have limited sub-base sections, so limited structural support, also limited subgrade supports as well. And you also have limited inputs in terms of the traffic type that you're seeing and how much traffic you're seeing. So you're limited in what you can really do with those existing design guides. So they're a good place to start if you've never designed a parking lot and you're looking for good information. ACI design guides have a lot of good information, but in terms of actually designing the pavement, it's a little bit limited in what you can do. Additionally, these ACI 330 design guides are actually based on the same methodology as Pavement Designer. So the 2008 guide was based on street pave design runs. The new guide that's just coming out is actually based on Pavement Designer design runs. So it'll actually be a one-to-one comparison if you're looking at ACI guide versus using pavementdesigner.org. It's actually the same design methodology. So Pavement Designer is really a robust tool for designing parking lot parking lot concrete pavements. Okay, so a little bit about Pavement Designer's methodology for designing concrete pavements. It's using a modified version of the Streets module that we'll see a little later on. And it's modified that way for a little bit for simplicity's sake, a little bit to be more focused on the type of loading that we would see for parking lot facilities. And so you'll see if you compare what you see in the parking module versus the street and local road module, it's a little bit different, but it's based on the same methodology. A little later on, I'll tell you the difference, the exact differences, so you can better understand that. But it does allow you for designing different design lives, different reliabilities, different percent slabs cracked, and these are things that you can't really control in those ACI design guides. So a little extra flexibility. All right, so let's take a look at a parking lot design using pavementdesigner.org. So we're going to keep it a really basic design where we're designing for a bus terminal that features, that serves about 50 buses a day. And we know that we have an existing subgrade that's a clay soil, fairly weak type soil, something that we typically see here around us in the Midwest. All right, so let's switch over to pavementdesigner.org. Okay, so if you go to pavementdesigner.org, as I mentioned, it's a free tool, so you can go to pavementdesigner.org and start designing without even creating an account. So you don't need to create an account to start designing concrete pavements with Pavement Designer. You just have to go to the website. Now, I have created an account. I've used it quite a bit because I do Pavement Designs quite a bit. And when you do create an account, all you need is an email and a password. We don't require any extra information. So it's fairly simple to sign up and create an account. The big benefit of creating an account is that you can actually save your designs online and you can access them from anywhere, any computer that you have. So comes in handy. We'll see the My Designs features in a little bit, but let's go through and actually do that parking lot design that I just described. So first thing we have to do is start designing. So we go ahead here, click on Start Designing, and you'll see that we're brought to our first decision point. And so the first thing that we have to do is select what type of project that we're going to do. We can do a parking lot, street and local road, intermodal, or industrial type facility. So if you hover over any of these tiles, you'll actually see you've got a little flip screen. And it gives you a little more detail on what's featured within each of these modules. So the parking lot module is really focused on any type of parking facility. So any place where we have cars, buses, or trucks, this is where you really want to go. So even if you had an intermodal facility that was really just housing, really just used for loading trucks, you may still be in the parking module rather than the intermodal module. So I'll touch on this a little bit more a little later, but the intermodal module is really more for, say, forklift type loadings or really any type of non-over-the-load vehicle that would be featured in the parking lot design. So that's a little bit of the difference between the parking and the intermodal design. So we're going to focus on the parking design. We're designing for a bus terminal, 50 buses a day with a clay soil. That's all we know so far. All right, so we've selected a parking lot design module or parking lot design. You can see each design module within Pavement Designer is broken into a three-step process. We have our project level details, our pavement structure details, and our summary details. So we try to keep it as simple as possible and focus on the critical inputs. So the first thing that we have to do within our project level details is choose our traffic spectrum. And so our traffic spectrums that are already loaded into Pavement Designer, we have ACI 330 traffic spectrums. You can see when we start selecting spectrums, you can actually see the traffic summary details begin to change. And so the traffic spectrum that really corresponds to a bus terminal is ACI Spectrum C. That's corresponding to their new design guide. The ACI Spectrum C is directly corresponding to city buses. And so you can see here our traffic summary details. This is giving us the axle loads that our pavement's going to be exposed to, and the number of trucks, the number of those axle loads our pavement is going to be exposed to per 1,000 trucks. So if I had 1,000 trucks, my pavement would be expected to see about 18 single axles that had 31,000 pounds on them, and 23 axles that had 30,000 pounds on them. And then you scale that up for every 1,000 or for however many thousand trucks you have. So it's just a little background on the traffic summary details. Don't actually have to know that, but it's a good information to know. So the next input that I have is my design life. So here as a designer, I have to determine, do I want this bus terminal to last 20 years, 30, 15, somewhere in between there. We can really have flexibility here in terms of how long we want this pavement to last. So I'm going to choose 20 years for this design life. The trucks per day in this term, in this example would be 50 buses, as we've said that 50 buses is what we're designing for. So we have 50 buses per day. So 50 buses over 20 years is quite a few buses. So you can see how that would propagate out through these traffic summary details. So next we have is reliability and percent slabs cracked at the end of our design life. Here we have to kind of determine where we want to be, keeping in mind that since this is a low volume facility, that's also going to be a slow speed facility, we're probably going to have a lower reliability than we would say with a collector street or say an arterial or a highway. So our reliability is going to be a little lower than we would see in those types of scenarios. So here we're probably going to be somewhere around 75% for our reliability. And our percent slabs cracked is going to be somewhere around 15%, maybe 20%, depending on how conservative you want to be. So I'm going to say 15% slabs cracked at the end of my design life. So now that I've filled in all of my traffic and global details on the project level, I can move to my pavement structure details. Okay, so in my pavement structure details, I need a little information on the subgrade, the concrete materials, as well as the structural layers in between my concrete surface and the subgrade, so the sandwich layers in there. Now, all that I know about this facility that we're designing for right now is that I'm designing on an existing subgrade that's a clay soil, so it's not a very good support system. So in the parking lot module, you can see that we have a few descriptors that are describing various soils. We have this first one that's silts and clays. We have this one that's sands and sand gravel mixtures, and then sand gravel mixtures that are free of fine particles. So we know that we have a clay soil, so we're going to be in this low support realm, and we can just select that. And so when we do that, it's actually going to populate our subgrade CBR value and give us a resilient modulus. So if we actually have a subgrade value that we know, we can actually go in here and override that, say it's a CBR of 4. In that example, you can see how it's going to change where that support system is. I know that I'm going to design for a CBR of 3 in this example. Okay, so the next thing that we need is a little information on our concrete strength and our modulus of elasticity. So we can define our concrete strength based off of a number of different factors. It can be a flexural strength, a compressive strength, and define it based off the modulus of elasticity, or the split tensile strength. So in this example, let's say that we know compressive strength. We're fairly familiar with concrete. It's going to be somewhere around 4,000 psi. And so I can define the design strength based off that 4,000 psi. You can see Pavement Designer actually calculates the flexural strength, and it's going to be around 580 psi. So we have these built-in conversions, but Pavement Designer is actually going to use that flexural strength in the design process. So that's, if you have flexural strength, it's best to just go with flexural strength rather than converting from these other strengths. But the conversions in here are fairly common and fairly often used. Okay, so the next thing that we need is our structural details, our structural layer, our layer information. And so you can see here, we can have 0 subbase layers, or we can actually put in a subbase between our concrete surface and our subgrade. So if we have a subbase layer in here, you can see that we can define it a number of different ways depending on what type of layer it is. Or we can just place the concrete pavement directly on the subgrade, which may be the case in some type of parking scenarios. So when we do that, it actually calculates the composite K value of the substructure. Basically anything underneath the concrete surface is combined into this composite K value. That's how we design concrete pavements. Okay. So we have our K value of our substructure. It's automatically calculated. We could override it if we wish. I'll show you that a little later on. But we've basically completed all of the main design steps before we get to the summary. So let's move on to the design summary. Now, once we get to the design summary, you can see that we've got a calculated minimum thickness, a recommended design thickness, and we've got a maximum joint spacing. We've got some sensitivity plots. So here's where we really determine, are we happy with our design? Or do we need to go back and change some of our inputs to kind of be more of what we would expect for this type of facility. So you can see our calculated minimum thickness is 8.14 inches in this case, and we have a recommended design thickness of 8.25 inches. The recommended design thickness is always going to round up to the next quarter inch. So here as a designer, we can actually look at this and determine, okay, should it be 8? Should we design for 8 inches, or should we specify 8.5 inches? We're probably not going to be anywhere, or we're probably going to specify on the 1/2 inch. So Pavement Designer is giving us that flexibility where we can see what the actual minimum thickness is that required for this design life and what our recommendation would be. So should we go up? Should we go down? Gives us a little flexibility in there. It also calculates a maximum joint spacing, and that's giving us our recommended joint spacing to make sure that our panels don't get too big where we might risk cracking. Okay, so these sensitivity plots are also very handy in terms of seeing how our design may change based off of some of our more popular design inputs. So the first one is that K value. That's defining the support underneath our concrete pavement. You can see that changing our K value does not have a hugely significant impact on the required concrete thickness. That's fairly consistent with what we see with other design methodologies as well. We know that the underlying layers are not having a huge impact on the concrete thickness. And so here we had about a K value of, I think, around 100. So if we increase that a little bit, we may cut off a quarter inch, a 1/2 inch, depending on the type of design that we're doing. So it's interesting to see how our design may change if we change some of the pavement properties as we went along. And so we can go back into our pavement structure and change the K value or the concrete strength based off of these properties and have an idea of what the pavement design is going to change to. So it's a fairly good tool in terms of what we can do with that. We also have, we can see how the design life changes this. We can see how the reliability changes this. As I mentioned, we probably don't want to go too high with our reliability, as this is a low volume, low speed facility that's not seeing a whole lot of traffic. So we're in here around 75%. If this was, say, a collector type facility or an arterial, we may be up here in the 90 to 95% range, and we may see some additional thickness required. And then we have percent slabs cracked, kind of the inverse of reliability. If we want to have very few percent slabs cracked at the end of our design life, we're going to need some extra thickness. Of course, then we're not really failing the pavement at all anyway. Okay, so we also have cracking and erosion tables, and I'll talk about these when we go through a street design. And then we also have joint spacing. So this joint spacing is really basically giving you an idea of how this joint spacing was actually calculated. So where does that come from? Why are we recommending 15 feet? Why not 17 or 18 or 20? Or why not 14 or 13? This gives you a little bit of information on how that was calculated. Okay, so on Pavement Designer, you can actually generate a report as well. So if I generate a report, I can actually provide some additional information, design name. So in the parking example, you can just provide a designer's name, route, zip code, owner agency, a little bit of extra information. And then we can click download and view report. And if you have a pop-up blocker on, you'll have to disable that for Pavement Designer, and then you should get the, there it goes, loading a little slow. You should get the report right there on your screen, and you can actually see all the different layers and all the different inputs that we had throughout the design. It'll also download to your downloads folder as well, so you can have a copy of that design report. Okay, so if you're logged in and you've created an account, you can also actually save that or save this design, and that'll save the whole design for you. So you can see I already typed in the design name. I can choose a project folder, or I can create a folder and I can actually save it. And so if I want to come back to that and revisit later on or talk to somebody about it, I can save it if I've created an account, and then I can access it in my designs. And so within my designs, you can see I've used Pavement Designer quite a bit. I have quite a few folders with various examples through here. I just saved this parking example here, and you can see it's saved down here. And then so when I have those saved designs, I can either go in and I can edit those designs, or I can actually create a duplicate of it if I want to change one of those inputs and keep a copy of both designs. I can actually send this to somebody. So if I wanted to share it with Art and say, hey, can you take a look at this? You can type in his email address and it'll send him a copy of it. and then he can look at it and tell you what he thinks, or he can send it to me and I can tell you what I think. And then you can delete these designs as well. So you have a lot of features that you can access by just creating an account with your email and password, and that's all we require to do that. So it's fairly easy, and it's got some good extra resources there too. So speaking of resources, Pavement Designer has a fairly good library of resources that are related to pavement design. And so this is a good library of various resources related to pavement design, and it relates to all of the different types of designs that Pavement Designer can do. As I mentioned that map a little bit earlier, you can see the Pavement Designer map and methodology is right there, one of the first things that we have. We also have some intro videos in case you want to rewatch me going through one of these designs. We'll give you a little detail on how to do that. A lot of good resources from ACPA, from the Concrete Pavement Technology Center as well. So all of these are free, great things for relating back to pavement design. Alrighty. So the other thing that I want to show you guys on our first tour of Pavement Designer is the support section. And so this is a place where you can actually find the contact information of the national associations that kind of contributed to the development of Pavement Designer, as well as all of our state associations. You can find the contact information. Say if you're designing outside of North Dakota and you're looking for arts counterparts somewhere else in the world, you can go here and you can actually find the contact information for those various states depending on where you're working on a design for. So another good resource on pavementdesigner.org. Alrighty, so that's our first tour of Pavement Designer and goes through the parking lot module. So let's see here, we've gone through the parking lot module. Next up, let's go in and talk about the street design module. Let's talk about how we design concrete pavement streets, and what all is featured within them. So, as I mentioned, with designing concrete pavements and streets within Pavement Designer, you have a lot of different things that you can design for. We can design for our conventional jointed plain concrete pavement. We can design for overlays, whether they're bonded, unbonded, on asphalt, on concrete, doesn't matter. You can design it with Pavement Designer, and it's fairly simple. We can also design RCC or continuous reinforced concrete pavement. We can also design composite pavements within here as well. So a lot of versatility within here. If we're designing a street and local road, we're doing full depth concrete or concrete, as you see here in this picture, and we'll see how that looks in a little bit. We're going to focus mainly on the jointed plain concrete pavement here, but know that the same design process for jointed plain concrete pavement, you'll see basically the same 1, 2, 3 types steps for designing for each of these different types of facilities. You may just have some extra inputs that you have to deal with depending on the type of design you're doing if it's not a conventional full depth concrete pavement. All right, so similar to parking lots, let's talk about some of the other ways we would design municipal streets and local roads that you may be familiar with, and what some of the benefits and drawbacks are of those design methodologies. So here we're actually going to talk about AASHTO 93 for a few minutes. We're also going to talk about AASHTOware's Pavement ME design tool, which is kind of a Cadillac, the best way to design concrete pavements that exist these days. There's also ACI 325 design guides and StreetPave. So let's go through these briefly and talk about what the differences are in these designs and what the benefits and drawbacks are. So our first one is AASHTO 93. And if you've ever done a pavement design, you've probably either used AASHTO 93 or at least heard of AASHTO 93. So AASHTO 93, as the name implies, has been around since 1993. It's nearly as old as I am, so it's getting fairly old, but it's actually way older than that. So AASHTO 93 is based on the AASHTO road test, which was performed between 1958 and 1960. So all of the observations that we had from that road test are what have been built into AASHTO 93. It's evolved a little bit over time with the 1986 guide, the 1972 guide, and the interim guide before that. But it's all still based on the AASHTO road test of the 1950s, which was performed in Ottawa, Illinois, close to where I'm at in Rosemont. It's about a 2-hour drive. So it's really based on that AASHTO road test where we basically built 6 test loops and we built concrete and asphalt sections. We loaded them for 2 years. We observed how they performed, and we built that into the design, the AASHTO 93 design equation. So all of that is based on the observations we had at the AASHTO 90 or the AASHTO road test. So it's very empirically based. It's based on those observations from those 2 years. So it's based on a very limited inference space. We had limited materials that were local to Illinois. We had limited structural sections because, as you can imagine, we had 6 test loops, so we didn't have an extensive amount of sections. We had, I think, around 360 concrete sections, so a reasonable number, but not huge. And again, local to Illinois with Illinois materials, Illinois soils, and we had 2 years of traffic data. So that's all we had. We had 2 years of traffic data. So not a whole lot of traffic information either. So we had limited structural sections, limited traffic, and limited observations. And that's what's built into the AASHTO 93 design guide. Now, you can see here some of the examples of the asphalt and concrete sections. Notice that a lot of the concrete sections were fairly thicker. This is because the AASHTO road test was, and the AASHTO design guides are really focused on highway type pavements. They're built for interstate type facilities, highway pavements, very heavily trafficked roadways. So a lot of our concrete sections tend to be thicker. And you'll see why that's one of the drawbacks in a few seconds. You can also see some of the trucks that were loaded on the AASHTO road test. After those 2 years, they had about 1.1 million load repetitions of these types of trucks. So a fairly limited amount of data that we're actually designing with. Now, at the end of the AASHTO road test, here's one of the big problems with the AASHTO 90, the older AASHTO design methodologies. At the end of the AASHTO road test, about 30% of our concrete pavement test sections were failed. So 70% were still in decent condition. Now that's a big problem when you're doing a road test because you're trying to get a full performance characteristic history of how concrete pavements perform throughout their life. So if you don't fail your test sections, how do you know how your pavements are actually going to perform? And so this is a big problem with the AASHTO, the older AASHTO empirical design methodologies. They're based on limited inference space where we don't actually know how the concrete pavements are going to perform. So we had to predict how they perform. So we have different projections of how this would actually look. And now we're designing pavements for up to 100 million design or load repetitions. So way outside of the inference space of the AASHTO road tests. And so that's a big problem with with using the AASHTO 93 design guide for designing concrete pavements is we really had to project how pavements were going to perform outside of the inference space. And so that's a problem. And so this was actually recognized by the General Accounting Office of the United States. You can see the title of this report, Highway Pavement Design Guide is Outdated. They're talking about the AASHTO 93 and the guides before that as well. It's outdated. We know that we can do better. And so that's why AASHTO created Pavement ME Design, the new pavement design tool for designing concrete and asphalt pavements. But Pavement ME is really made for federal and state agencies. It's made for high-level highway type pavements, interstate pavements. It's not really made for streets and local roads and parking lot types of facilities. So it's a great design tool, and it's really kind of the best way to design concrete pavements, but it doesn't really lend itself well to trickle down to smaller type facilities or agencies that don't tend to do pavement design a whole lot. It is fairly complex. You can see here what Pavement ME actually looks like. And there's a lot of information that goes into it, which is what helps make the design and analysis process more accurate. But if you're not familiar with the design process and you don't have all of the good information needed to run the design, it can become very complex and very difficult to do an accurate design. And that's one of the reasons why we don't see Pavement ME adopted. It hasn't been adopted by all of our departments of transportation. It also is not trickling down to cities, county highway departments, and some consultants that don't do pavement designs all the time as well. Additionally, it's fairly expensive. One license for 1 year of Pavement ME is around $6,000, so it's very expensive. But again, it's for more of the DOT type facilities, which is why we don't see it used all the time. Now, if we compare AASHTO 93 to Pavement ME, you can really see why it's such a better tool for designing pavements. You can see here how the inference space has changed, what the data that these methodologies are built on, how it's evolved over time. So if we look at AASHTO 93, it's based on that 1.1 million load repetitions. So that's the limited amount of traffic information that's built in there. Now we're designing for 50 plus million load repetitions. That's why Pavement ME kind of has test sections all over the country, those long-term pavement performance sections. And we're actually evaluating how our pavements evolve over time. And so that's built into Pavement ME. It's kind of a really cool feature. Additionally, we had one set of materials local to Illinois in AASHTO 93. Now we have materials from all over the country, and we've seen how they perform in different environments. We have climate data from all over the country, not just 2 years of climate data from northern central Illinois. We also have structural sections, way more structural sections than we've ever had before, because we're building this off of data from all over the country from various long-term pavement performance sections. So we've really kind of blown up the inference space, and we have so much more information that Pavement ME is built on. Additionally, the ME part of Pavement ME is mechanistic empirical. So we've actually tied in the mechanistic predictions of how pavements are going to perform. And when we have that mechanistic prediction, what those stresses and strains are of our pavements and how we can predict the actual performance based off of those, and then tie it back to the empirical performance that we see in the field, that's how we get the best pavement prediction and best pavement analysis tool. That's why Pavement ME is such a robust tool for designing concrete pavements. However, it's complex and it's costly, and that's one of the big reasons why we developed Pavement Designer, because it's another mechanistic empirical tool that's not as complex, and it's obviously free. Now, again, it's more for streets and local roads. It's not for those interstate type facilities, but it can do those types of things as well. And we'll see that in an example here in just a few minutes. Okay, so another way that we can design for streets and local roads is the ACI 325 design guides. Now, these are very similar to the 330 design guides. We have our design tables. They're fairly limited in what we can do, but they will get you started in terms of what you're trying to do. But again, these are based on street pave runs, and the new guide is based on Pavement Designer runs. So it's actually using the Pavement Designer design methodology already. So that's great. So let's talk about Pavement Designer and where the roots are in terms of the design methodology. So Pavement Designer for roadways dates back all the way to the 1960s. So we originally developed this back in the 1960s. It's called the PCA method back then. It's evolved, and we've improved it over time. In the 1980s, there was a big step forward when we introduced erosion into the design model, and then we released it as street pave in the 2000s, and then updated it again in 2012 to become street pave 12, and now we've released it for free as pavementdesigner.org, and it's featured within there. So it's a fairly robust tool that we actually look at failure criteria such as cracking and faulting or erosion, which is good because that's how our concrete pavements actually fail. If we revert back to, say, AASHTO 93, we're really designing based off of a serviceability index, which is kind of grouping all of the stresses together rather than actually looking at the stresses over time. So here we're actually looking at the stresses, cracking, and erosion. And this design methodology was more tailored for streets and roads. We basically recognized that the AASHTO road test was for highways, so we needed a design methodology for streets and roads. And so the PCA method was born. Now, Pavement Designer has actually been approved by the Minnesota Department of Transportation for their cities and counties. And this was a fairly recent thing. They actually just released this in November of 2020. They basically did a research study and looked at how it compared to their own in-state design module, which is MinPave Rigid, and they found that it was comparable, and so they allow for the use of pavementdesigner.org. So it's very exciting that your neighboring state is actually looking at using pavementdesigner.org for its intended purpose, its city streets and county roads, which is exactly what it's been built to do. So just a little aside there as well. So let's actually take a look. Let's design a municipal street with Pavement Designer. So we're going to design for Overland Parkway. We've got about 100 trucks per day, and we've got an existing subgrade that's a poorly graded silt. So let's take a look. All right, so if we go back to Pavement Designer, you can see that I'm still here in my saved projects. Let's go ahead and start a new design. See here, I've got if I'm going from here, I can actually enter my design right off the bat. Let's say Overland Parkway. I'm going to do a street design. And again, we have these flip screens, so if I'm not sure if I'm designing an overlay or a full depth concrete pavement or a composite pavement, you can see those flip screens give a little more information on what's featured within each of these modules. So if I go into my full depth concrete pavement, you can see that we're back to our 1, 2, 3 step process. So project level details, pavement structure details, and our summary details. So first thing that we have to do is select a traffic spectrum. Now, all I know is I have about 100 trucks per day. It might be a collector, it might be a minor arterial, I'm not really sure. So I'm gonna go ahead and turn on help screens. So you see this help question mark here on the top right, you can turn this on and off. I usually have it off because I use Pavement Design quite a bit. So you can turn it on. And so every time when we turn on the help screens, we have these hoverovers. They give us a little information about the input. But if we click on more information, we can see we've got a lot more detail on what this input actually is and what might be a good input for this type of facility. So I know I have about 100 trucks per day. So if I look in my traffic, my trucks, average daily truck traffic, I'm going to be in here. I'm going to be 100 falls between 40 and 1,000. So I'm going to say I'm a collector type traffic category. All right. So I know my traffic category now is a collector. You can see here I've got a little bit more a few more traffic spectrums within the street module. I can also add a custom traffic spectrum in here as well. So I believe you have to create an account and log in to do that because it saves on your account, but you can do it as well. Next thing we have to do is determine our design life. Again, we have to determine this as designers, determine what it needs to be. So I'm going to say 30 years. I know I've got 100 trucks per day. So the next inputs that we have are traffic growth rate, directional distribution, and design lane distribution. We didn't have these for the parking lot, so we've got to figure out what these need to be. So for traffic growth rate, if we're in an area that's growing fairly rapidly, we may be around 5, 6, 7%. If we're in a place that's fairly stagnant, it may be only 1 or 2%. So let's say it's growing fairly aggressively. Let's say it's about a 5% traffic growth rate is what we're expecting over those 30 years. And then directional distribution. So I've got 100 trucks per day. If they're split evenly going, say, northbound and southbound, I would say 50% of my trucks are in my design direction. If I know that all 100 trucks are in the northbound direction, I would say 100 trucks per day in my directional distribution, or 100% of my trucks are in my design direction. Similarly with design lane distribution, here if I say have 2 lanes going in my northbound direction, I may say that 90% are in my design lane and 10% are in my passing lane. You can see here if I click on my more information, you can see if I have, say, a 4-lane facility, 2 in each direction, I may have 90% in my design lane, 10% in my passing lane. So let's say I have a 4-lane facility and I've got 2 lanes in each direction. So I'm going to say about 90% of my traffic is in my design lane and 100% of those 100 trucks are in my design direction. So last thing we have are reliability and our percent slabs cracked. So let's take a look at reliability. No collector, it's probably going to be somewhere in the 85% range, which is exactly what we see here within our help screen. So about 85% for our collector would be a good idea as a starting point. And again, once we get to the summary, we can see how how all of these inputs impact the design, and we can change this with those helpful sensitivity plots. Excuse me. All right, so the next thing we have is our percent slabs cracked, and it's going to be about 15%, somewhere 10 to 15% is usually pretty good. So one thing that we didn't have in the parking lot design that we have now in our street design is calculated traffic results. So this is basically taking that 100 trucks per day and that 5% traffic growth rate and those directional and design lane distributions, applying all of that over, say, 30 years and averaging it out for a daily traffic that it's designing for, about 200 trucks a day. And if we look at how many trucks over the entire design life we're designing for, we're at about 2.1 million. So that's what's kind of calculating through this design process. All right, so we filled all that out. We can go on to our pavement structure. Here we can determine if we're doing a full depth jointed plain concrete pavement, which is our conventional concrete pavement. We do RCC or CRC. So we're going to just stick to jointed plain concrete pavement. You'll see that if you play around with those other two, they're very similar in terms of what you're required to put to input. They're just designing for a slightly different type of pavement. Okay, so we know that we have an A5 type subgrade, but we don't actually have those helpful little click buttons that we had in the parking lot design. So if we turn our help screens back on and we look at what a resilient modulus would be for an A5 type soil, you can see that we have a good little chart here that can give us an idea of what, say, an A5 soil would be. So a resilient modulus might be between 5,000 and 8,000 PSI. So we could choose something in there, or we could choose a CBR value between 4 and 8, and that would roughly be about what we're looking for. So I'm going to be conservative. I'm going to go on the low end and say 5,000 PSI is my resilient modulus for this design here for my specified A5 type soil. All right. So next thing we need is some information on our concrete properties, our flexural strength, or compressive strength. Again, we have those handy little conversions. Here, I'm just going to say I know I've got a flexural strength that's going to be around, let's say, 550 PSI. We need a modulus of elasticity. And then we have two little yes or no questions here that we can use for design. They are, do we have macro fibers in our concrete, and do we have edge support? So macro fibers in our concrete, this is something that we don't usually see with full depth concrete pavements, but if you're designing for an overlay or a thinner type, maybe a thin concrete pavement or a thinner overlay, you may see macro fibers used within your concrete pavement. If you're looking for more information on that, I'd recommend you look on the CP Tech Center's website. They've got a lot of information for designing overlays and designing overlays with fibers as well. Additionally, you can determine whether or not you have edge support. So edge support in Pavement Designer is defined as anything where you, say, have a widened concrete lane, say it's 13 feet wide and you stripe it at 12 feet, that would be considered edge support. Additionally, if you have, say, a tied curb and gutter or a tied concrete shoulder, that would be considered edge support as well. If you have an asphalt shoulder or a gravel shoulder, that would not be considered edge support. So in this example, I'm going to assume that Overland Parkway has a tied concrete curb and gutter, and so that would count as edge support. And so with that edge support, it's basically reducing the stress on that free edge, and so it's helping carry the load a little bit. So that's what's happening when we choose edge support for our design. So the next thing we have is sub-base layers. So here we can choose 0 layers and place our pavement right on the subgrade, or we can choose up to 3 layers for our concrete pavement. So let's say that we have 2 sub-base layers in this example. So the first one, we're going to choose, say, a granular base. You notice that we have some default resilient moduli in here, so it's fairly easy to select. And let's say the layer thickness is about 4 inches, a little thin layer, granular base. And then let's say we have a cement stabilized subgrade below that. And we're going to say we have, let's say, 5 inches of cement stabilized subgrade underneath that granular base. So now it's going to take that granular base, that cement stabilized subgrade, and our resilient modulus of our subgrade, and calculate a composite K value for us. So you can see here, it calculates it as 332 PSI per inch. If we wanted to override that and say, well, we think that might be a little high, we want something a little more conservative, we can go in here and we can say, okay, I want to use a user-defined K value of 200 PSI per inch. So now we've got 200 PSI per inch. That's what it's going to design with. We can move on to our design summary. Okay. So in our design summary, you can see here that we've got both doweled and undoweled thicknesses. So whether or not we're using dowels can be a decision that we have. We have our minimum thickness and our recommended design thickness. Again, taking that minimum thickness and rounding to the next 1/4 inch. And then we have our maximum joint spacing. So we have all of these for doweled and undoweled options. You'll notice in here that in this scenario where our recommended design thickness is 6.5 inches, we may not want to use a doweled pavement, at least maybe not our conventional round dowels. It may be difficult to get those within such a thin pavement. We may want to consider plate dowels or maybe fibers as an alternative, or maybe just do an undoweled pavement, which is likely what we would see being the proper scenario in this design. And so if we're looking for a little more information on whether or not we should use dowels, we can click on the load transfer tab, and we can see where we recommend using dowels, where they may not be recommended. And you can see what size dowel bars are recommended to use as well. So you can see less than 8 inches, we're likely failing by a cracking, and so we may not actually need dowel bars, as faulting and erosion may not be a problem. So let's actually take a look at that. Let's take a look at our cracking report and see if cracking or fatigue is really driving our design. You can see here in our cracking table that we've used nearly 100% of our fatigue life or our cracking life. And so you can see here which axle loads. These are going back to the project level details with various axles that we're designing for. And you can see which ones are actually causing the most damage, which ones are consuming our fatigue life. And you can see it's mainly the heaviest of the single axle loads that are causing the most damage here. Tandem axles tend not to cause as much fatigue damage. If we look on the erosion, the faulting side, you can see here that we're not consuming a whole lot of our erosion life. And this is because we're in a doweled scenario. If we switch over to undoweled, you can see we see a little bit more faulting and erosion, but it's still not significantly high. So that tells me that we're really failing because of fatigue. We're failing by a cracking rather than faulting. So you can see here, tandem axles tend to be more damaging on the erosion side. Okay, so we still have all of our sensitivity plots. We have our load transfer tab. We also have that joint spacing tab telling you how this was calculated and why this is our recommended maximum joint spacing for this design scenario. So we've got a lot of good information to help inform the design that you're doing. So there's a lot of good information here as well. So we still have our generate report. We can also save if we've logged in and created an account, and we can go through in here and we can go back and change any of our inputs that we had, and go back and edit our design however we want. So a lot of good freedom in terms of what we can do with Pavements.org. So let's go back to our presentation. Let's take a look at another design example. And so this is an actual design that I received, and somebody said, hey, can you look at this AASHTO 93 design and tell me if you think this is realistic, knowing that what we've seen over the years is that AASHTO 93 tends to result in overly conservative, unnecessarily thick concrete pavements for various types of designs. So the design that they had about 8,000 trucks or around 20 million easels, if you're familiar with AASHTO 93. Doesn't matter if you're not. They also had a 90% reliability with 5% slabs cracked. They had a 6-lane facility. They had an R value of 20, that's defining the subgrade. They had a modulus of rupture or a flexural strength of 630 PSI with an elastic modulus of our concrete of 3.5 million. They assumed edge support, so they had a tied concrete shoulder or a widened slab. They had an asphalt subbase on a cement stabilized subgrade, and they assumed a K value of 160 PSI per inch. Okay, so the AASHTO 93 design that was performed came up with 11 inches of concrete. So real quick, let's go through and see what Pavement Designer comes up with in this type of design. So let's start new design. Oh, don't want to save. Let's go ahead and start new design. Go ahead and start projects. I'm going to go to concrete pavement streets, full depth concrete pavement. And all right, so we're going into our design. So I've done this a few times, so we're going to go a little quick through this. So we have to select a traffic spectrum. It was a major arterial. Their design life was for 20 years. And they had 7,860 trucks per day. And they, I assume, say a traffic growth rate of about 2 or 3%. We assume directional distribution of 50% and a design lane distribution of around, let's say 70%. Based on our help screen, we know that when we have 3 lanes in one direction, about 70% of our trucks are going to be in that outside design lane. All right, so they specified a 90% reliability and 5% slabs cracked. So you can see here we're designing for quite a few trucks, 24 million trucks. Again, trucks not the same as easels, so don't be surprised that those easels and number of trucks don't quite line up. Okay, so if we move on to our pavement structure details, let's put in our subgrade details. They had an R value of 20, and they had a flexural strength of 630 PSI, 630, and they had a modulus of elasticity of 3.5 million. So they did not have macrofibers, they did have edge support, and they had 2 subbase layers. Let's see here. An asphalt subbase layer at 1 inch and 6 inches of cement stabilized subgrade. Okay, so that's a fairly stiff structure. You've got an asphalt layer, you've got some cement modification of the subgrade. So it's a fairly stiff structure, but they were designing with a K value of 160 PSI per inch. So being fairly conservative with that. So let's move on to our design summary with these design details. Okay. So you can see that with this design, our predicted minimum thickness is around 8.5 inches. So it's a fairly big difference from the 11 inches that we saw with AASHTO 93. Now I know that can scare off a lot of people, but that's typically what we see when we get into significantly high traffic volumed types of facilities, and using AASHTO 93, which wasn't really made for that type of traffic loading for the various reasons that we talked about a little bit earlier. So we have a pavement designer design of 8.5 inches, AASHTO 93 of 11 inches. How am I possibly supposed to understand the difference between here? Well, we've talked about some of the differences between AASHTO 93 and Pavement Designer. So let's see what Pavement ME has. So Pavement ME, again, is AASHTO's current design tool. It's their best design methodology for designing concrete pavements. It's something that we've really embraced as we've seen the benefits of doing mechanistic empirical design for concrete pavements. You can see here, the Pavement ME design came out at 9 inches, so right around where Pavement Designer was, given those various inputs. And so I did both of these designs. I did the one with Pavement Designer. I did the one with AASHTO 90 or with Pavement ME. And you can see with Pavement ME, the cracking is kind of what's driving the design. It's what's getting closest to failure, but still, they only predicted 9 inches of concrete was required for this type of design. So it's really great to see those two lining up, because again, they're mechanistic empirical approaches to pavement design. So they result in pretty realistic numbers for the pavement design. All right, so the last thing that I want to touch on with the street design module, and I'm going to go real quick through this because I'm running out of time, and I've got one more thing that I want to cover, is there is a module within Pavement Designer where you can actually estimate the traffic given an existing asphalt design. So let's say that you have that you're a county and you know that your typical asphalt section or the typical pavement design that you have is, let's say, 3 inches of asphalt. Let's do what I've got printed here. 4 inches of asphalt on 8 inches of granular base. So 4 inches of asphalt on 8 inches of granular and a resilient modulus of around 4,000 PSI for whatever you're designing for in this case. So if that's all of the information that you have, you don't typically do a pavement design. You typically just stick with that example that you have, 4 inches on 8. That you may be used to using that, but you may also want to see what a concrete alternative might be for that type of facility. So if you want to do that type of analysis where you want to do a concrete design that's comparable to that, you can see in here, if we go to, let's say we've got a collector type facility and we know that we want it to last 20 years, we can go in here and instead of doing user-defined traffic info, we can actually estimate it from an asphalt design. And so this is going to take that existing asphalt design that you may be familiar with, that may be what you always pull out of that 4 inches on 8. And it's going to create it's going to figure out how many trucks a day that pavement is going to hold given that 20-year design life. So I said granular base. The layer coefficient for granular base is usually around 0.14. There we go. 0.14 to 0.16. And then a thickness of, let's say, 8 inches. And this is going to be based on AASHTO 93, because AASHTO 93 is kind of the main design that's used for asphalt pavements for this type of facility. And let's say we've got a resilient modulus of 4,000. So you can see the other types of inputs that we need for an AASHTO 93 design. So it's going to actually calculate the structural number. It's going to calculate the flexible ESOLs. Then it's going to calculate the average trucks per day and the trucks over the entire design life. So it's calculating that based on that assumed 20-year design life that we have and the type of traffic that we have here. So it's basically saying that if we want this pavement to last 20 years, based on AASHTO 93, we would assume that it's only going to carry about 50 trucks a day. So that's kind of what's going on here. The liability was determined in there, and so beyond that, you'd have to provide a percent slabs cracked, and then the rest of the design would be just like the design. Oh, I went too fast. Computer's lagging a little bit. So the rest of the design would be exactly how we show the design for streets and local roads. Okay, so I'm running out of time very quickly, and there's one last thing that I want to show you guys. It's the intermodal industrial design. Before I get to that, I should mention the differences between the parking lot design and the street design. I promised I would tell you guys that. So again, the parking design is a simplified design, so we have limited traffic spectrums. We also assume a growth rate of 0%, and directional and design lane distributions are defaulted to 100%. We also do not allow fibers, and we do assume edge support. So we assume all of that in the parking lot module. So if you copy these in your street design, it will exactly match up with the parking lot design. So that's a little bit on the differences between the parking and street design. Okay, so last thing that we're going to cover, we're going to talk briefly about the intermodal design. Now, before we get into this, or while we're getting into this, I should mention that we are in the process of updating this, making it a little more user-friendly. So if you've used it before, or if you're looking at it now, you may see that it's a little more complex than the other designs that we've talked about. But we are working on making that a little more user-friendly. So look for those updates sometime here in 2021. So intermodal design within Pavement Designer is really looking at designing for really heavy type vehicles like forklifts or container loaders. It's not really looking to design for over-the-road traffic like your conventional trucks. If you're doing a facility that's just designing for trucks, but it's an intermodal facility, use the parking lot design or the street design. That's going to get you your best design. This module is really for these types of vehicles, your forklifts, any type of non-over-the-road vehicle that still has pneumatic tires that may be significantly overloaded. It's designed for those types of vehicles. So you can see the other ways that we can design these intermodal type or industrial type facilities. ACI 330 does have a pretty good guide that goes through how to design for these types of facilities and the things you need to watch out for. They do actually list ACPA Street Pave, which again is the precursor for Pavement Designer. They also list Pavement ME, which we've talked about. Great design methodology, not really great for designing for forklifts and container loaders and stuff like that. And they also list TC Pavements and OptiPave, which is a good tool. It's not used a whole lot in the US, but it is used quite a bit in South America and other parts of the world. And then they list ACPA's AirPave. So ACPA's AirPave is actually developed for designing for aircraft, but it can be used for designing for these types of vehicles where you have some odd shaped loadings, odd tire and stress distributions. And that's what's actually used in the intermodal industrial design within Pavement Designer. And so let's do a real quick example as we're finishing up here. We're going to design for a Cat 986 loader, 130,000 pounds, 12.5 foot wheelbase with 10-foot axle width, and a tire pressure of 90 psi per inch, or 90 psi. Okay, so going back to Pavement Designer, let's go back to our home. We can start designing. Again, intermodal. So here basically goes, or our little flip screen tells us that we're looking at non-over-the-road traffic. We're looking at container loaders, excavators, any type of vehicle that has pneumatic tires that wouldn't fit in the over-the-road type traffic. So you can see here that we actually have a database of vehicles already developed within Pavement Designer. So you can actually select from these vehicles. You'll see the 986 loader that we're designing for right here. We can select that. We directly select on that. You can also create a custom vehicle. Now, to do this, you have to be logged into Pavement Designer, but you can create a custom vehicle. You can determine how many wheels this vehicle should have, where the position of those wheels are. First one should always be at 0, 0. You have to have a vehicle name. It's called Eric's Bike. You have to have the gross weight of the vehicle. I hope I'm not up to 30,000 pounds yet. And contact pressure and contact area. So there's an interrelationship between these three that you need to understand: the gross weight, the contact pressure of each tire, and the contact area of the entire thing. And that's one of the things that we're updating here in 2021 is this interrelationship will be a little easier to define, but it's not quite in there just yet. So let's stick to our Cat 986 loader. So that's the vehicle we're designing for. Then we can move on to our pavement structure details. You can see that we've got everything just like we've seen before. So we're going to go through this really quickly. We're going to put that right on the subgrade. All right, let's see what our design summary says for this Cat 986 loader. It says we need about 10 inches of concrete. And so you see that we don't have quite the other sensitivity plots that we had with the other design modules. It's one of the limitations of this design methodology, but you can see that we're basically, we've got the design thickness and the minimum thickness for this type of vehicle, and this is pretty much designing for however long, or for the entire life of pavement. And so that's another thing that we're looking to add in is number of load repetitions in case you have a vehicle that's not used every day. So we are looking at updating this, but you can use it right now and still play around with it and look at how the intermodal industrial design is done within Pavement Designer. And so with that, I think I'm just about out of time. I hope you guys have learned something about pavementdesigner.org today. If you do have any questions, please feel free to add them in the chat box, and Art can either pass them along to me or I can try to respond to them. Additionally, Brian Killingsworth, I believe he's on our agenda today. He's another great guy who knows a lot about Pavement Designer. He was on the solution team developing this tool. So a lot of good brain knowledge about pavement design. If you have questions, I encourage you to ask them or reach out to us after the fact, Art or myself. Be happy to answer any questions you have about pavementdesigner.org. So thank you. I'll turn it back to you, Art.
All right. Well, excuse me. Thank you very much, Eric. That was a fantastic presentation. A lot of information to cover there on a really great free resource that hopefully will be beneficial and used more with our pavement design community throughout North Dakota. We don't have any questions in the chat box right now, and so if anybody does have questions, either later today or next week, whenever, please feel free to reach out to me, and I will make sure that we get all of those answered, and we will follow up with you offline. Before we move forward, just one other quick announcement. I did mention that we had the door prizes. If you are unable to accept a gift, certainly we don't want to get anybody in trouble. So if you want to opt out of the prize drawing, please let Savannah Schmidt know. You can send her an email, and Savannah will make sure that your name is removed from that. Certainly not our intent, and thank you to some of our attendees for bringing that to our attention. All right, moving on. So we had a very great and thorough discussion on pavementdesigner.org, the free online design software tool. We're going to transition to our next topic, and our next speaker is Brian Killingsworth. Brian is Executive Vice President of Local Paving for the National Ready Mix Concrete Association. Brian provides technical support and education to member companies, to affiliate associations, contractors, and local owners regarding concrete pavements. Prior to joining NDRM&CPA, Brian was a consultant for 20 years and conducted work with both concrete and asphalt pavements. It should be also noted, as Eric mentioned, that Brian was instrumental in pavementdesigner.org as well, so he is well versed in a number of areas, and we are very, very happy to have Brian Killingsworth joining us now to talk about designing and constructing resilient, sustainable pavements. So with that, please welcome Brian Killingsworth.
Thank you, Art. I appreciate that introduction. Got my screen shared, and I think hopefully everybody should be able to see it. So we are going to talk a little bit about how we design and construct resilient and sustainable pavements. Before we get to that, though, we really need to kind of define what does it mean to be resilient and what does it mean to be sustainable. So first thing we want to look at is resilience, and that's the ability to resist, absorb, accommodate, adapt to, transform, and recover from the effects of a hazard in a timely and efficient manner. And that can apply to a lot of different things, a system, a community, or to a society. So it's kind of a very broad-based definition. If we want to get it to something that's a little more in line with what we're talking about today, we're talking about transportation systems and pavements. That definition from the FHWA would be the ability to anticipate, prepare for, and adapt to changing conditions, and withstand, respond to, and recover rapidly from those disruptions. So that really, in a nutshell, is kind of what resilience is, and you have a disaster of some sort, a hazard of some sort, and then you respond to that, and how quickly you respond to that really kind of defines how resilient that asset or that structure is. So that's resilience. When we talk about sustainability, we're talking about the pavement's ability to achieve some sort of a goal, an engineering goal for what it was constructed for. And hopefully what we can do is preserve and maybe even restore some of our surrounding ecosystems through the construction of that pavement. And then we're also going to use our financial, human, and environmental resources economically. That's the kind of that triple bottom line that we talk about, the social, economic, and environmental. And we also want to make sure that we meet basic human needs, such as the health, safety, equity, employment, comfort, and happiness. So that's kind of what I'm going to claim sustainability is. Now, when we talk about sustainability, we're talking about a kind of broad impacts. We tend to think about sustainability in terms of our greenhouse gas emissions, right? So we think of it here. We tend to think of CO2 equivalent or carbon burden, that type of thing. What does our infrastructure, our pavement, how does that impact us environmentally? And we tend to always think about greenhouse gases, but there's a lot of other things that sustainability can mean in terms of how much energy consumption, or am I saving energy in some way with that asset? Does it impact habitat and water quality, or that hydrologic cycle of rain absorption, evaporation, that type of thing? Am I impacting air quality or the mobility, the community mobility by adding a pavement or adding a lane? That access to the rest of the community, how we move freight, all of that type of thing can also be an impact when we talk about sustainability. So just kind of keep that in mind as we go through. Now, the one thing that I want to make clear is that sustainability and resiliency are not the same thing. They can be compatible, but they're not necessarily equal. And what does that mean? Well, remember we said resilience is that ability to respond to some sort of a hazard or a natural disaster. We can build a pavement that is very resilient, but it may not necessarily be very sustainable. So we need to understand that they can kind of co-live together, sustainability and resiliency. But just because we build something sustainably does not mean it's resilient, and vice versa. When we build something resilient, it's not necessarily sustainable. So those two things are different, can be different. They can be compatible with one another, but one doesn't mean the other is going to occur. So let's talk about resilience a little bit. Again, get a little bit deeper into what it means, but also when we're talking about how do we design and construct resilient pavements. So again, resilience is that ability to anticipate, prepare for, and adapt, and then withstand, respond, and recover. So if we have some sort of an event that occurs right here, we will lose performance, right? So we'll lose the ability for that asset, for that infrastructure, for that pavement to perform adequately. So there will be some sort of a recovery time, and then we'll kind of be back either near or at or near our performance, or maybe be even above our performance prior to, sorry about that, prior to that hazard or event happening. So what this green line shows here, it shows that it is more, this asset is more resilient than, say, what happened here, because it took longer to recover, and we did not recover up to the performance that we had prior to the event. The green shows, well, we in fact recovered quickly, and we're at that same performance. Now, we can actually build structures to where they will rapidly recover, And maybe even by what we do during that recovery period, they may be even better in terms of performance than they were before. And when we talk about an event, what we're talking about is something like flooding, maybe wildfire, earthquake, that type of thing. And we'll talk about that just a little bit more here. So when we're talking about impacts to pavement, climate impacts, what do those impacts entail? That can entail temperatures. What we're seeing with climate change is higher average temperature, higher extreme maximum temperatures, warmer extreme minimum temperatures, so we're not getting as cold, severe cold, and then maybe more freeze-thaw events, particularly in areas where we tend to see significant winters. What we may see is more freeze-thaw events that occur in those regions. When we look at precipitation, we may have higher than average precipitation over time, maybe wetter winters, drier summers, low summer humidity, and more extreme rainfall and flooding. We talk about extreme events like droughts, floods, wildfires. What can that do? Well, it can affect subgrade moisture, particularly when we talk about droughts. We can have a decrease. What we may see with flooding is more frequent roadway inundation. So they're flooded, the substructure of our pavements is flooded. And then with fires, we may see more in terms of frequency and also larger in terms of size wildfire fires. We've seen that here the last few years. And then we also can maybe have sea level rise where we see more frequent roadway inundation as well. So what are the impacts to pavements directly? With temperatures, we may see expanding slabs, and we see those blow-ups that we've seen maybe out in the desert west. We may have more significant curling and warping to our pavement, so we have loss of support. We may see our subgrades in our base weakening a little bit. So we have poorer performance with our pavements. We may see subgrade heave more, particularly when we go from drought to very high moisture content in our subgrades. And then also we may see some embankment instability along the sides of our pavements as well. So we have pretty significant impacts from our climate. When we're talking about pavements, the most significant impacts to our pavements, whether they're roadways or airports or intermodal facilities, whatever, we typically are seeing that flooding is our most significant risk to our pavements. Things like tornadoes and wind, drought, heat, wildfires, while they may have some sort of an impact to the pavement, really when we talk about operating cost and the funding gap that we have in terms of keeping our infrastructure at a certain level of performance, flooding really is the big issue, the biggest risk. And there's three different types of flooding. The first would be severe flooding from natural disasters. Think of our eastern coast, think of the Gulf Coast, and in particularly Houston. Houston, over the last several years, has had several significant flooding events, the worst being Hurricane Harvey. So we have hurricanes, we get tidal rise, we get significant rain, and we have flooding that can occur, and our pavements can be flooded and inundated for a very, very long time. Sometimes it can be weeks. And when we have that, we have a reduction in strength of our pavement, typically below the surface. Another way flooding can occur is in the plain states. We may see significant river flooding going over the embankments during the snow melt, the springtime. So we can have significant flooding. We tend to see that in these plain states here, where we get overtopping of our river banks and we get the significant flooding. And again, we'll see portions of our roadways that are flooded for a very long time. And then in our coastal zones, with sea level rise, whether it's a permanent rise in sea level or more frequently now, tidal rises, so daily changes in tide can actually flood streets. We see that a lot in Delaware, Florida. A lot of these coastal cities will see this tidal sea level rise that occurs throughout the day. And again, we can have that inundation of the pavement that can cause us problems. So we talked about inundation a little bit. There's actually two different types of flooding that can occur. The first one there on the left is what we call washout. So that's where you get a really rapid flow of water, very high current, and that basically scours away the material below the pavement and eventually into the pavement, and the surface is washed away. Now, the pavement type, whether it is a flexible pavement or a rigid pavement, really has no impact on the ability to resist scour. It's just going to happen. Not much we can do about it in terms of the pavement type. Where pavement type really does make an impact is when we're talking about inundation. Several states, several counties and cities have looked at the difference between the ability of a flexible pavement or a typical asphalt pavement over top of granular material to recover from and perform adequately after inundation. We see a big difference between flexible and rigid pavements. Rigid pavements tend to recover quicker, and we don't see as a significant loss of performance with concrete pavements. So that's a little bit about sustainability, and we'll talk in just a minute about some of the things that we do to design to incorporate sustainability into our designs. We'll talk about that, incorporate resilience into our designs. We'll talk about that in just a moment. So resilience we've talked about. Let's talk about sustainability a little bit. And really, what's important about sustainability is not necessarily that we can design for it, but that's important. But the other part to it is we need to be able to report how sustainable our infrastructure is. And the way that we report, and then also the way that we assess whether we are doing a better job in terms of our sustainability, our environmental impacts. We need to be able to report that adequately and then also be able to determine how much better we are doing. So let's talk about that a little bit. So when we talk about sustainability, there's two things that we need to keep in mind. One is what we call embodied carbon, and the other is operational carbon. So this is the impact that we are going to have with our infrastructure, with our pavement. When we're talking about embodied, what that means is it's the release of CO2 or some other sort of impact, whether it's release of methane, whether it's an impact on our rivers and streams, whether it's air quality, whatever sustainable impact or environmental impact that we're looking at. When we are creating that asset, when we're manufacturing, when we're transporting raw materials to our manufacturing infrastructure, when we are transporting that material to construct that asset, that's what we call embodied carbon. The operational carbon is the energy that is used as we are using that asset. Think of a building, for example. We can build a building and we will have measures of our embodied carbon. And then when we use the building in terms of, think of air conditioning and water use and that type of thing, that's what we would consider our operational impact, or in terms of carbon, our operational carbon. So there's two things that we talk about, and to get a full sense of our life cycle, we have to combine the total embodied carbon with our operational carbon to give us a full accounting of the impact. So what might that look like for a pavement or a building? Well, we start here in terms of extracting raw materials. And when we do that, we have some sort of greenhouse gas emission. And then we have to transport that stuff to the factory. We have to manufacture it. Then we have to transport it to our construction site, construct it. All of that is embodied carbon. When we use our building or our pavement, that's our operational carbon, but there's also embodied carbon that's allocated in the use phase. And then at the end of the life of that infrastructure, we demolish it, we haul it away, and we take it to a landfill. Again, that has embodied carbon as well. So just important to understand those two things when we're talking about environmental burden or impact. Now, when we are talking about sustainability, there's a couple of different things that we can do. This is kind of that reporting portion that I was talking about. One is we can simply disclose to somebody, a buyer or an owner or a government, whatever the case may be, what our environmental impact is. So we would be disclosing, the impact that we have. The other is we want to be able to look at our infrastructure and compare different types of materials and say, all right, well, this one does a better job in terms of environmental impact than this material does, or this pavement structure does. And so that would be comparing. We utilize what we call environmental product declarations to do that disclosure. And basically what all that means is that owner, that buyer, they want to look at kind of across the board when they build that infrastructure, what is my environmental impact going to be? And I can ask each person that manufactures for that pavement, for that building, to tell me, to disclose to me what that environmental burden is. When we actually want to make decisions, we have to do what's called a life cycle assessment. And that incorporates the entire life cycle. When we're disclosing, what that can mean is we're only taking and disclosing a certain portion of our environmental impact. And I'll show that on a graphic here in just a minute. But when we actually want to compare and make a decision on which material is better, that's when we use the full life cycle assessment. That's called cradle to grave. So when we are doing a material disclosure and an environmental product declaration, what we're typically looking at is just cradle to gate. And what that kind of looks like is a food label. So on a food label, it tells you what's all my vitamins and minerals that are on here, and then also what are my impacts in terms of fats and sugars and things like that. And so a environmental product declaration, or an EPD, would do basically the same thing. What it's going to tell you is kind of the energy that's required to make that material, and then what those operational impacts are. So we get an operational and an environmental impact that's reported out. Okay, and again, that's from cradle to gate. So we can use those EPDs in a few different ways, and how well those things are verified is what gives us the validity of that EPD. So what does that mean? Well, there's a couple of different ways we can develop an EPD. There's this option 1 and option 2. In option 1, what we're doing is we can report 3 different ways. One way we can report is just for the manufacturer of that material to just kind of self-declare and say, all right, this is my environmental impact. Nobody checks his numbers. Nobody does any kind of validity check. Nobody really looks at and verifies whether things are correct. It's just somebody stating it, and that owner then must kind of take their word for it. We can go to the next level where what we may do is say, all right, if I'm going to produce concrete to build a pavement, I can look at all of the different concretes that I might use to build that pavement, you know, with 3,500 PSI with straight cement, or 3,500 PSI that maybe has, you know, 60% cement and 30% of our fly ash in it, okay? And I can report that. I can get all of that data. I can, you know, work the numbers. I can have somebody that verifies it. And we can generate EPDs that are called an industry average for each of those performance levels, that 3,500 with the different types of materials and a 4,000 with the different types of cements and materials. And I can use that to report to an owner. So that's a next level better. The other is to say, all right, for this particular job, I'm going to use this mix from this producer. And that producer is going to provide a product-specific EPD that is also verified. All of his numbers are verified. Everything that he did in that process to determine that environmental impact is going to be verified. All right, so that's one way we can disclose. The other way that we can disclose is by saying, you know what? I'm going to show you how much better I am than the average, the industry average, or some other type of material. So I can utilize the EPD to demonstrate how I reduce my environmental impact from some other level, some benchmark that is set, or from the industry average. So we can use EPDs a lot of different ways, but primarily all we're doing there is disclosing. When we talk about cradle to gate, what we're talking about is the location at which we stop our accounting of our environmental impact. So you can see here, we have our production stage, our construction stage, use, and end of life. An EPD typically just kind of covers this portion, the cradle to the gate. So cradle being pulling that material that we need from the ground, essentially. So we're extracting our resources, we are manufacturing it, and then we're getting it as far as to the construction site. And that's all that we're accounting for in terms of our environmental impact. All this other stuff we're not accounting for in terms of our environmental impact. It's just that kind of early portion of the manufacturing stage. So if we want to be able to incorporate all those other stages, the construction, the use phase, the end of life phase, we have to incorporate what we call life cycle thinking. And we know this already because we do this in the pavement arena in our life cycle cost analyses. But simply all life cycle thinking is to reduce a product's resource use and the emissions to the environment, as well as improve its socioeconomic performance through its life cycle. So that extraction of raw materials all the way through that life cycle to the end of its use. And again, we do that a lot with life cycle cost analysis. We look at things like our initial cost. What does it cost us to maintain it, rehab it? What's it cost our users when we're using that pavement? And then what is our residual value of that pavement at the end of its life? So we do that in life cycle cost analysis and kind of evaluate our economic considerations. So it's an accounting, right? So we're doing financial accounting there. Same type of thing when we do environmental considerations. Basically, all we're doing is accounting for that environmental impact at the resource extraction, the processing, the placement, the use, the maintenance and rehab, and at the end of life, what do we do with that asset or structure? Do we recycle it? Do we leave it in place? You know, what's the benefit if there is a benefit at the end? So in here, instead of accounting financially, what we're doing is accounting for our environmental impact, typically, which is greenhouse gas emissions. So that would be here. okay, those greenhouse gas emissions. But there are a lot of other impact categories that we can look at. You know, what is our energy used to manufacture and use that asset? Resource use. What's the toxicity to my environment by building that resource and using that resource, that asset? Okay, so just like with the EPDs, we're reporting typically our greenhouse gas emissions. We do that same thing in terms of our life cycle assessments, but we just have to understand that there are a lot of other impacts that we actually can report. The next thing to think about when we talk about making decisions, using that life cycle assessment to make a decision, the question is, within that process of building our asset, when do we make a decision about what's best in terms of our environmental impact? So do we do that in the pre-design stage, in the design stage, during procurement, construction, or the use phase? So it's important for us to be able to recognize we're going to make a decision based on our environmental impact at a certain point in our construction process or in building that asset. Typically, when we are doing, say, life cycle cost analysis, we typically do those during the design stage. Okay, and we can do a life cycle assessment at the design stage as well. We just have to understand that we can make those decisions at different times within that whole kind of procurement process, the pre-design, design, the actual procurement and contracting, constructing and using. We have the opportunity to do those life cycle assessments at all these different points. The other thing that's also important to understand is what criteria are we going to use, who does the analysis, and can we really compare results, because that becomes important. Many times if we do an LCA that has different boundary conditions, we can't compare LCAs of differing types of materials. So if our boundary conditions are different in terms of our manufacturing, for example, between concrete and something else, then we cannot really make a decision about which one is better in terms of its environmental impact, because we're comparing apples to oranges, not apples to apples or oranges to oranges. So it's important to understand what those boundary conditions are and whether or not they're the same for those materials and whether we can compare. So we see that here. You know, many times what we want to do is choose a sustainability winner, right? What we want to say is design A wins over design B, C, or D. Okay, and that's not really the best way to utilize either an EPD or an LCA. All right, what we typically want to do is choose the material that we're going to use because it's the most materially efficient. And then what we do is optimize and economize that design so that we are reducing that kind of environmental impact of that material. Okay, so it's difficult to make material choices utilizing an EPD and an LCA. All right, so that's very quickly an overview, not very quickly, but it's an overview of resilience and sustainability. Let's talk a little bit about how then we can utilize materials and designs and asset management, things like that, in terms of incorporating green elements. We know that we can utilize low impact materials to achieve some of our sustainability goals and some of our resiliency goals. There's many ways that we can do that, and I'll just touch on a few. One would be utilizing something called Portland limestone cement. We know that cement and the manufacture of cement has an impact on our environment. It's a fairly intensive CO2 manufacturing material. And if we can reduce the impact by utilizing what's called a Portland limestone cement, then that's a great option for us. And what that is a blended cement that has additional limestone content, and it's optimized for whatever performance it's going to be used for. It's a really, really easy way to reduce your carbon footprint by about 10%. And it can be used in buildings, bridges, pavements, geotechnical applications like stabilization of soils and things like that. And PLCs are readily available throughout the US and Canada. So you can get them from your cement suppliers fairly easily. And we can demonstrate this. So if we were to look at several different concretes, for example, one just being an average 3000 PSI concrete, straight cement, nothing else, no fly ash or slag in it, we would see our global warming potential of about this. If we use some fly ash, we can see it go down a little bit. If we use some more slag, we can see it go down even more. If we were to take and utilize a Portland limestone cement in lieu of just the Portland cement, we would get about another 10% additional decrease at each one of these levels. Okay, so PLCs are a great way to be able to lower impacts in our concrete for either pavements or for buildings. Another thing that we can do is use a different type of cement. One, it's a cement where we are utilizing the benefits of what's called carbonation. So one thing we can do is in terms of manufacturing, we can change the way that we manufacture our cement a little bit by adding CO2 actually into our manufacturing process. Okay, and so when we inject CO2 into that cement manufacturing process, we can actually cause that CO2 to chemically react, and it allows us to use less limestone in our manufacture of cement. We can use lower kiln temperatures in the manufacture of our cement. So we produce about 30% less greenhouse gases. So we're actually taking captured carbon and utilizing that in our manufacture of cement. We could do the same thing in the manufacture of some of our aggregates, okay? So we can take captured carbon from, some other industrial manufacturing. We can capture that carbon and we can inject that or sequester that into some aggregates, okay? And so we can sequester CO2 by kind of changing the aggregate, if you will. So it's another way in which we can lower our impact is by using captured carbon in our aggregate development. And then another one that we can do is right during the midst of our concrete manufacturing, so at a ready mix plant, we can actually inject CO2 into that manufacturing process, and it creates an artificial limestone as it goes through a reaction. As you're mixing your cement, your water, your aggregates, you inject that CO2, and then it sequesters that CO2 within the concrete. It enhances the compressive strength a little bit, and it also reduces the cement content. So there's some significant benefits through this enhanced carbonation or this injection of CO2 at different points into the concrete manufacturing process. And then, of course, most people know about pervious concrete. This is what we'd consider a sustainable material because it's an open graded system and allows water to flow through it. And when we allow water to flow through it as runoff from rain, it actually kind of cleans that water before it hits the water table. So we're reducing our total suspended solids, reducing our metals like zincs and irons and things like that, and also nutrients from runoff that comes from fertilizers and things. We're kind of capturing all of that stuff here, retaining it here, and by the time the water hits the water table, it's clean. So a lot of different ways in which we can impact our pavements in terms of our environmental impact just by using low impact materials. And we can also use recycled materials and things like that. So there's a lot of ways that we can impact our environmental burden. Let's talk about things that we might do to lower the environmental impact during the design stage, and then also how we might improve resilience. One way that we can do that is just changing the way that we do pavement design. Eric did a great job taking us through the pavementdesigner.org. So he gave us kind of an overview of how we might do a pavement design. And typically what we do in pavement design now is this. We say, all right, I'm going to start out with my climate, my soil conditions, my traffic, my concrete strength, right? And I'm going to evaluate that against some performance target. And, the performance targets that Eric was talking about was fatigue life and erosion and faulting. Okay, so we look at a set of pavement layers and thicknesses, and we analyze whether or not it meets our performance requirements. That 15% slabs cracked, or that we want to be below a ½ inch of faulting. All right, and we kind of go through an iteration process to tell us how thick our pavement needs to be. Once we do that, then we develop what's called these life cycle bill of activities. So that would be all of that cost data and all of that environmental data that we would need to do our life cycle cost analysis and our life cycle assessment. So we're basically doing this LCCA and LCA once. We do the iteration to make sure that we get the right cross section, but we only evaluate its life cycle impacts once. We can actually change that process to where we incorporate the LCCA and LCA in optimizing our pavement design for economics and for environmental impacts. So what we would do here is we would say, all right, we're going to start out with some inputs. We'll evaluate those inputs, develop those life cycle bill of activities, apply all of our cost and all of our environmental data, and then evaluate it in terms of our life cycle cost criteria and our life cycle assessment, our environmental criteria. So we establish those criteria and we say, well, does it meet that performance or does it not? If it doesn't, then we go back up and we change our pavement structure and maybe the materials that we use to where we can finally kind of iterate on what would be our most economic and our most environmentally impactful pavement design. So if we change that methodology a little bit, we can be a little bit more impactful in the design stage and make sure that we are reducing our burden both economically and environmentally. So if we do that, what we find is that, let's say we just did a couple of things. Maybe we used recycled materials, or we just went from 2 rehabilitation cycles to 3 rehabilitation cycles. We can see we wouldn't have a really significant impact in our environmental burden. If we optimize here in terms of that process I just showed, it shows that we could potentially have very, very significant environmental and economic reduction, burden reduction. So represents a real clear win-win situation if we change just that methodology a little bit. One thing I talked about was that washout versus inundation, and what we showed, or what research has been showing, is that just simply by adopting a hard, stiff surface, i.e. concrete, we can produce more resilient and potentially more sustainable pavement cross sections. One city that has kind of applied all of that knowledge is Riviera Beach in Florida. They're one of these that tends to have a lot of coastal flooding that can occur from either hurricanes or from tidal changes. and they went through a very significant rebuild of some of their sewer and water utilities and things like that. And they went from an asphalt surface road to a concrete surface road because they were finding that their concrete surface roads and other portions of their city were actually performing much, much better, even when they got flooded. So if we can just simply start by using concrete, that helps in terms of resiliency and potentially sustainability. Now, in terms of designing for resilience, one of the things that we can also do is base our designs on the weakest subgrade condition. So think about a subgrade when it is completely saturated. It has a significant amount of water and moisture in it. Generally, if it's a clay subgrade or silt subgrade, we'll see very, very significant loss in strength. And so if we simply design for a very weak subgrade, we can help make that pavement cross-section more resilient. We'll make it more resilient. It may not necessarily be the most sustainable pavement design because it may require more materials. So you might have to do a little bit more optimization to make it sustainable as well, even if we are making it more resilient. So this is a case in which we say we can make something more resilient, but not necessarily more sustainable. All right, so that's the design phase where we can impact sustainable or resilient. So let's look at the asset management stage, or what we would call the use stage, or maybe the maintenance and rehabilitation stage. A lot of different ways that we can talk about it. But in terms of asset management, what we do is we take, over time, we kind of take snapshots of how well that infrastructure is performing, whether it's lighting or signage or traffic control devices or drainage structures, roads, bridges, whatever the case may be. What we're really interested in is how can we impact things from a roads standpoint during our asset management decision-making stages. So when we're talking about pavements, asset management is really what we capture in terms of our pavement management systems. So what we do is we gather a bunch of data about our pavement structures, right? The thickness, how well they're performing, how long they've been there, the maintenance and rehab cycles that we have performed. We capture all of that data, and then we segment it based on our network. And we get kind of a state of the network. We get a current state of the network, and we can produce reports, we can produce performance histories and things like that. So all of that data in our pavement management system can then help us decide what are the maintenance and rehabilitation strategies that I need to apply to my network to make it economical and sustainable. So essentially what we do is we take all of that data that we've gathered, we evaluate it, and we kind of predict what our performance is going to be going forward. All right, and then we make decisions about what are the best treatments that I can apply to my pavement so it'll perform adequately over time. And so we kind of optimize that. You know, is an overlay the best idea? Is crack sealing the best idea? Is concrete pavement rehabilitation through grinding the best idea? So we kind of select the treatments and determine when those things need to be applied. Now, how can we make that more sustainable? What we can do is do LCAs during that decision-making phase. So when we're trying to decide what's that best maintenance or rehabilitation technique, we can then incorporate those life cycle thoughts about the materials and what the environmental impact would be in that decision-making stage. So what might that look like? Okay, so here again is our pavement management system up here. And we're going to evaluate certain treatments based on what our pavement management system tells us. So what we would do is then conduct that for each treatment, we would conduct that LCA, and it would tell us what our greenhouse gas emissions would be. And we can get a full accounting of what our life cycle would be on the environmental side. And then we can also do a full accounting of what our life cycle cost would be for the economic side. And then we can make a decision about what the best treatments are and when, based upon kind of optimizing for the environment and for our economic considerations. Other things that we can do during that use phase is, we talked about all these different types of treatments. Well, we can apply things like concrete overlays. They can be sustainable, and they can also help us in the resiliency side. So how would that occur? Well, if we have just a flexible pavement right here and we load it, we know that that stress is applied all the way through that pavement. So let's say during a rain event or a flooding event, what tends to happen is these layers right here can become very, very weak. And so what we tend to see is an increase in distresses that can occur when these layers are inundated and weak, because all of that stress is being carried in those weak layers. If we add a concrete surface to that flexible pavement, essentially what we're doing is moving that stress burden up here into the areas of the pavement that are hardened, that basically can handle all of that stress. And when all of this down here is wet, it doesn't have that much of an impact. So we can recover quicker and we can perform better and achieve that performance quicker. So concrete overlays are great because they can be sustainable and they can be resilient. We'll talk about concrete overlays in just a minute, but basically all you're doing with overlays is you're preparing that surface, cleaning it, you put the concrete right on top of it, you texture it, you cure it, and then you joint it. So a very simple process that we'll get into a little bit more detail, I think, in the next segment. Another thing that we can do is what's called full depth reclamation. When we do full depth reclamation, essentially what we're doing is changing again these weaker layers into something that's a bound layer that's stronger. And so if this does get wet, this would weaken. If this got wet, it wouldn't weaken as much. Okay, and so that's whether it's water coming up from the bottom or water coming from the top. And again, all we're doing here is we're taking the existing asphalt pavement and granular base, we're pulverizing it, adding some sort of stabilizer to it, and then we put a new surface on top of it. So again, that's something that can be done during the use phase, the rehab phase. And then the very last thing that we'll talk about is when we do make our pavement stiffer, we actually reduce pavement deflection and pavement roughness. All right, so when we reduce deflection, make things smoother, when we actually traverse the pavement, we can use less fuel, and if we use less fuel, we can have a lower environmental impact. So using stiffer materials can help us, and that can help us not just on a single project, but if we apply that over our entire network, we can lower our environmental burden as well, and potentially also be more resilient. So in summary, we talked about resiliency and sustainability are good. They're compatible generally, but not always equal. We can disclose or quantify sustainability different ways. And then we can also become more resilient and sustainable at different stages within our life cycle. So Art, that concludes it for me. Hopefully, yeah, just a couple minutes over. I guess we'll defer questions until later so we can get to the next one.
You know, I think we do have perhaps time for just a couple of questions. I know I ran long with my opening announcements. One written in here, Brian, that says, can weigh-in motion scales be installed in a concrete surface, and how much is the calibration impacted by air temperature?
Yeah, so that's a good question. Yes, weigh in motion can be installed. There are different ways you can do that. Some that are just directly on the surface, others that have to go into the pavement itself. I don't know enough about those weigh in motions to understand how much temperature would affect it. Generally what we see is a little bit lower temperature in lighter surfaced materials. So you can anticipate with concrete that you'll have lower surface temperatures. So that may prove beneficial, but I can't speak to how significant that would be.
Okay. And that's something too that we can maybe follow up on at a later time too, and get back to this individual. I had just two things I wanted to point out. Great presentation, and I appreciate you being here and going through all of this information with us, Brian. You covered a lot of ground today. And I really like the section on the life cycle thinking. I think that's a very critical component that we all are guilty of maybe not putting as much stake in, and that's something that should receive additional consideration. You mentioned that it can be done at any stage during the planning cycle. Is there one, in your opinion, that you think stands out better, a stage where it really should happen? Granted, you can always go back and do it, but in your thought process, what gives you the most bang for your buck?
Yeah, so there's, it really depends on what the desired outcome is. What it comes down to me is when we have the most information that's available to us to make the best decision. Sometimes we want to push that life cycle analysis very, very early into the process. If you do that too early, so, maybe even in the pre-design stage, if you do that too early, you just don't know enough to be able to make an adequate, meaningful decision. So generally, we want to be at the point at the project level where we know about our project, we know, some information about our subsurface and our environmental conditions, and we have sufficient data to be able to understand what the impact would be over the life cycle. So, generally that's going to be in that procurement stage, design and procurement stage. That typically is where you have sufficient information to be able to make a meaningful decision about what pavement system is going to give you the biggest bang for the buck.
Right. Yeah, thanks for answering that, Brian. There's a couple of other things, but I will, in the interest of time, we can follow up with those questions offline. I do want to take, before we transition to our final speaker, just a couple of minutes to also put a plug in for the Pave Ahead program through the National Ready Mix Association, which you are responsible for. A number of people on this call are familiar with this. We've utilized it in North Dakota to help design parking lots or review jointing plans. But could you give us maybe a 1-minute overview of what this service is and how the people on this call can really take advantage of it? And there's a theme here as well. Pavementdesigner.org we don't charge for. Maybe let us know what your fees are for Pave Ahead as well, Brian.
Sure. So the Pave Ahead program was developed to help users, to help owners, those types of folks that they know that pavement is an important asset. It's an asset that can potentially be expensive. But not everybody is familiar with how you really truly need to design a pavement so that you are economical and that you are addressing environmental concerns. And so what we did was kind of develop this Pave Ahead program to give some resources to those people and also to provide some services in terms of designing, helping in designing, assisting in designing. And so you can go to the Pavement website, and you can look through our resources, you can look through all of our education information. But if you really want some help in terms of getting an optimized design and understand how it's going to impact economically or environmentally, you go to that Design Center button, press that button, put in your information, and it will shoot an email to me. And I'll either contact you or somebody on my team will contact you. We'll help you through that process. And as Art mentioned, that process is at no cost. What we want to do is be able to support you, help you, and make things as easy as possible for you. We don't want to burden you with a fee to do that. Now, what that means though is we're not going to sign and seal plans, designs, that kind of thing. We'll give you all the information you need to go to your engineer and say, here's what I think is important. You know, go through this information and you know, get some help from the Pavement team if you need it. But we're here to support. We want to do that as easily as possible.
All right. Well, thank you, Brian, and really do appreciate you taking the time today. I know that we could spend a lot more time visiting about these topics, but we need to move on. So with that, we will move into our final topic today, which is concrete overlays for urban areas. Many of you are familiar with overlays. We've started to see them become more and more popular throughout the state in rural areas. A photo taken here shows an 8-inch concrete overlay on US Highway 2 that was constructed just west of Grand Forks last August. Perhaps some of you on the call were part of our on-site tour of that project. But again, as Brian mentioned, these are great ways to add additional service life to existing roadways by coming through and putting a concrete overlay into service. One of the things that we have not been so good at here in North Dakota, and the reason why I've asked our next presenter to be here, is taking this overlay technology and bringing it into our cities and using it for urban street repair. It's been done in other parts of the country with much success. And so that will be our final presentation this afternoon when we have Todd LaTorella. Todd is my counterpart. He is the executive director in the Missouri-Kansas chapter of the American Concrete Pavement Association. Since I've taken over in this position, Todd has been a great friend and full of resources and helped me out a bunch, and I really appreciate him being here today. You know, in addition to the credentials listed on his screen, he's helped move overlays from a viable option from rural to urban areas, which is what we think we could have some benefit from here in North Dakota. We've asked him today to join us to share some of the challenges so that we don't have to maybe go through some of the hardships that they've done and that they've learned the hard way. So with that, let's welcome Todd LaTorella to talk about concrete overlays in urban areas. Todd, thank you for joining us today. We look forward to your presentation.
Where to go? Thank you, Art. Can everybody hear me okay?
Yeah, we got you coming through loud and clear. Thanks, Todd.
All righty. I trying to turn my camera on here. I don't know where everything disappeared to, but it's not important. You really don't need to see me anyway. So, but thank you very much, Art. Appreciate the opportunity to talk to everyone today. Great presentation so far. As Art mentioned, I'm here to talk to you about concrete overlays for urban areas. We've had a lot of experience both on the highway network, which is certainly the challenges. While there are some, are certainly easier to deal with than in the urban areas that we'll talk about. So I'm going to jump in. I know I'm the last speaker of the day, so we'll try to keep ourselves on time here. So just a little presentation outline. First, just want to define urban concrete overlays. Briefly review the family of concrete overlays and design theory, just so everybody's on the same page and up to speed. Talk to you about some concrete overlay design basics. And really the crux of the presentation or the bulk will be showing you some actual applications. I think that's a better way to kind of show you what we've done. And when we talk about the challenges, you'll get a better picture of that through different types of applications that we've done in Kansas and Missouri. Quickly show you some available design resources, and hopefully we'll have some time for some questions at the end. So, all right. So my loose definition of urban concrete overlays, basically any application on a non-highway facility in an urban environment. And this can include arterial collector streets, residential streets, as well as parking lots. And I'll show you examples of both there. And here's where we kind of jump into probably the biggest challenge and the biggest hurdle that we have when trying to come up with a concrete overlay option in an urban environment, because typically these overlays and applications will involve profile grade elevation constraints related to existing curb and gutter, drainage structures, driveways, entrances, side roads, you name it, that will influence the design. It's easy out on the highway network when we have open ditches and we can raise that profile grade and we're not tying into too many structures other than occasional entrance and bridges. That's a lot easier than when we have existing infrastructure in an urban area, in an urban application, and we have to hit all these hard points. So, and this really differentiates urban from more highway and typical roadway overlay applications. Now, real quick, just so we're all up to speed and on the same page with our family of concrete overlays when we start talking about them. I know the other speakers kind of got into this a little bit, but here you see the 4 traditional concrete overlays and the overlay products that we've had as an industry, as a concrete paving industry. And basically over recent years, we've kind of just narrowed that down to 2 basic families of overlays. We have our bonded overlays and our unbonded, and we really don't care anymore what the substrate is or the existing pavement is underneath. We just want to know, are we looking at a bonded overlay design and application or an unbonded overlay? And so here we have our family overlays, and see on the left side here, we have our bonded overlay systems. When we design those, the bond is integral to the design meeting. The design works because it's bonded to the existing pavement in some fashion, and that bond remains over time, over the performance period of the overlay. Because we're building a composite section there and we have that bond, these overlays are typically thinner, of course. On the unbonded side, we're basically just using that existing pavement or substrate as a base. So we don't worry about bond. If we get some bond, that's fine. But the design itself it's not imperative to have that bond for the design to perform as or to meet our expectation. And so those overlays tend to be thicker. The best resource out there, and probably the only one you really need, is the Guide to Concrete Overlays out of the CP Tech Center. This is the 3rd edition. Great resource. Everything you ever wanted to know about overlays, from scoping, design, construction, traffic control, repair, you name it, it's in that guide. I think there's actually a new version of the guide getting ready to come out again. But this is really a great resource, free download, cptechcenter.org. So I encourage you to check it out. There's that 3rd edition. And so let's jump into the applications here so we can really look at what we're talking about. We're talking about these urban overlay applications. I'll start off with a real simple one, just to get everybody's feet wet. We're going to look at a bonded concrete overlay over asphalt. That's our BCOA. Is our acronym there. And this is probably the most common concrete overlay type for urban environments, or probably any environment, for a couple reasons. Of course, there's a lot of existing asphalt roadways out there, much to our chagrin sometimes, but that's what the existing system is made of. 90% of the roads are asphalt, so we have lots of overlay opportunities over in that market for BCOAs. And And profile grade elevation constraints are a little easier to deal with when we're dealing with full depth asphalt pavements. Asphalt pavements are a little thicker to start with than concrete pavements. It's easier for us to mill asphalt pavements to address that profile or that elevation increase. And we don't have to worry about any embedded steel, dowel bars, mesh in old pavements, tie bars, that if we get into milling concrete, we got to make sure we're aware of that. And sometimes that can slow us down or be a little more costly when we're trying to mill concrete pavements with embedded steel and reinforcement in them. Here's a little schematic out of the CP Tech Center overlay guide. Basically, it just shows you from existing pavement to finished product. You'll see there in the middle, that's the area where we're basically addressing the bond. So typically in these bonded concrete overlay over asphalt applications, we are going to mill the surface. So we're going to prep that asphalt surface. We're going to cold mill it. We're going to get it nice and clean. Of course, when we bond anything to something else, no matter what it is, we always need two things. We need a roughed up surface and increased surface area, and it's got to be nice and clean so we can get that bond between the two materials. So you're always going to have that when you have your bonded overlay application or design. Then, of course, as Brian mentioned, as far as the placement, not a lot different than conventional concrete. Just a little bit about joint design. This is probably the one thing in the construction that deviates the most from conventional concrete paving. Essentially, all the geometrical or the layout rules apply that apply to conventional concrete, but really the joint spacing for these overlays, especially the thinner ones, probably more of the overlays you're going to see in an urban area are going to be in this thickness, although we'll talk about a thicker one in a few minutes. But for these, 3, 4, 5 inch overlays up to 6, we really want to keep that joint spacing between about 3 feet to 8 feet. Really no bigger than 1.5 the thickness of the overlay. So instead of the 2 times rule we typically use for conventional concrete, we're going to be looking more at 1 to 1.5 times. Typically no dowels and tie bars in these designs or these overlays. Fiber's optional. There's a lot of advancement in fiber reinforcement technology. A lot of great fiber products out there that provide more of a structural enhancement to the concrete that make a lot of sense. They do add a cost, so we just want to make sure if we're going to use those, it's needed, and we're going to take advantage of that in a longer performance or possibly thinning up the overlay if we're going with a macro fiber type addition to the concrete. Saw on the joints, typically we're going to go less than 1/4 inch wide, kind of a single cut operation, 1/3 the depth of the overlay or slab, and for the most part we're leaving those unsealed. Now when we get into overlays 6 inches or greater, 6 inches always that right on the edge sometimes, but typically overlays 6 inches is greater, we're going to jump back to that 2 times rule where we can. I would probably still recommend, sticking to that 1.5. When I work with my consultants on urban paving projects, even full depth concrete, we're definitely reducing the slab sizes, the joint spacing. If it's 8, 9, 10 inch concrete, we're going with 12 by 12 foot panels, and kind of that configuration, and we're really getting great performance. You see, if you shrink that joint spacing down a little bit, you'll see very little chance, a little risk of getting some uncontrolled cracking outside the joints. And then you also want to be aware, as part of the joining rules, the thicker the sub base or the base we're putting that pavement on, so the stiffer that is, the shorter you want to make that joint spacing. So we want to alleviate some of those bending stresses in the slab. So if we shorten the slab and we're on a stiff sub base or base material, we always want to be wary of that and shorten up the joint spacing and design some smaller panels. Again, joints may be sealed or not, depending on the application. The industry still goes back and forth on that. I think a lot of us have some ideas about when we might want to seal joints and not. But for these thicker overlays, we can go with the conventional double cut joint construction and seal them, or we can stick with the single cut less than 1/4 inch and leave them unsealed. All right, so here we go. We got Project First Street in Abilene, Kansas. Basically, this was existing 9 to 12 inch existing asphalt pavement. It wasn't really that old. It was only about less than 20 years old when we built the constructed the overlay. And essentially, design was pretty simple: 5-inch cold mill, 5-inch concrete overlay or inlay. So just kind of mill and fill, but if you want to think about it that way, but with concrete. PCC mix, the concrete mix, nothing fancy. We did throw some microfibers in there at 3 pounds per yard, which that was fairly typical, probably in the early to mid 2000s. That was kind of a thought that, hey, on these thinner overlays, we're going to throw in a fiber mesh, was the hot fiber or the microfibers at the time, 3 pounds per yard. Help us a little bit with maybe some crack control protection, more with plastic shrinkage control. So we had those fibers in there. Just be aware that there is a difference between microfibers and macrofibers. So certainly if you're really looking for some structural type enhancement, crack control protection, maybe the opportunity to thin up your overlays, you're looking at the macrofibers. Joint spacing, nothing fancy here, 4.5 to 5.5 foot, and really that was a function of the street width more than anything. So based on the street width we had and laying out those joints, we ended up with 4.5 to 5.5 foot joint spacing. Again, we did single cut, less than 1/4 inch wide with no seal, no tie bars, no dowels. It was built in 2006 by one of our local contractors, Smoky Hill. And really, if you want to think about this, it's kind of a mix of the old ultra thin white topping technology we had and a white topping technology. And we've characterized this now as that BCOA, bonded concrete over asphalt. Just some shots of the project. You can see there's a grain elevator. Abilene's a pretty small town. Basically the home of Dwight D. Eisenhower and his presidential libraries in this town, but it's a pretty small town, but it does have a grain elevator, and this road serviced the grain elevator, so we had lots of heavy trucks that were rutting the pavement pretty significantly. So the city and the engineer came to us looking for a product to address that, so we ended up coming up with the 5-inch mill and fill with concrete. You can see there's the milled surface. We basically did half the street at a time. You see on that upper right picture, we got that surface nice and clean, exposing the existing aggregate in the asphalt, and that's really what you're bonding to here. Is you're bonding to that existing exposed aggregate in the asphalt mixture. You can see there we put up a little form, and they made a little keyway with a split piece of PVC pipe. Probably not necessary. I'm not sure if that was on there for another reason, another project, and they just use those, but we don't need that keyway there. You can see we brought out the paver. Basically just went from one end of the job to the other. Bottom right, you see the curing compound. We always want to do a good job of curing with concrete, especially on these thinner overlays where we're dealing with a much thinner section. We're often putting it on a fairly warm material. That existing asphalt can get pretty hot sometimes. So we want to keep as much of that moisture in the concrete, get that hydration process to do its work to its maximum, so we get the most durable and high performing concrete we can. So always, we don't like to see a lot of gray. We want to put that curing compound on 150 square foot per gallon. I like to see, make that surface nice and white. Just another shot once we got the one side done. strip that form off, just use the existing, the first phase as our form at the center line there. I actually brought a bunch of folks out from KDOT for a little showcase there. We went out to look at the project while it was under construction. That's why you see all those inspectors out there looking at the concrete going down. And there's a shot of the finished product and the finished project taken in 2013. Still performing really well after now 14 years. Again, 5 inches thick, nothing fancy, a little microfiber in there. Really quick to construct, great project, turned out really well. We've actually done a couple others in the city of Abilene for the owner. Another application here real quick, very similar type project, maybe a little higher traffic on the volume side. This is South 9th Street in Salina, Kansas, just 20 miles west of Abilene off I-70. Again, we had 11 inches of existing asphalt pavement. We did basically the same thing, 5-inch cold mill, 5-inch concrete overlay. So just again, a mill and fill with 5 inches of concrete. Nothing fancy about the mix. Again, 3 pounds of microfiber per cubic yard, kind of the standard that we were working with at the time. We had 12-foot lanes, so we went with 6 by 6 foot joint spacing. Again, just a function of the street width. Single cut, less than a 1/4 inch wide with no seal, no tie bars, no dowels. Opening strength, always something to really look at and really try to identify what type of opening strength you really need, because these overlay projects, especially in an urban area, you know, we're dealing with traffic, we're dealing with the public, we're dealing with businesses. One of the benefits of these concrete overlays, we can build them really fast, little inconvenience to the public. That opening strength can have a big bearing sometimes on how quick we can turn the project around, how much the mix is going to cost. So there's no reason to come, you know, what we're finding out is there's really no reason to have 3,000 and 4,000 PSI opening strengths. 2,500 is plenty. I think as an industry, we're probably even going less than that for these types of projects and not having any issues. This project was constructed fall in 2008 by one of our local contractors in Salina, Pavers Inc. Again, kind of a mix of the old UTW technology and white topping, characterized as a BCOA. Existing pavement was kind of just stretch of an arterial street between 2 intersections that were already concrete. So the city had already reconstructed 2 intersections on either side of this section of pavement in concrete. And now we had this existing asphalt street in between that they wanted to address. Basically very similar to the previous project. We just went out there with the milling machine, milled that 5 inches off. It's kind of nice because you can mill one day, put traffic, or days before, put traffic on that milled surface. Go out, get it cleaned when you're ready to pave and place the concrete pavement. You can see there they're basically blasting, sand blasting, air blasting the existing asphalt, high pressure air blast to get that surface nice and clean, as you see on the bottom right, exposing that existing aggregate in the asphalt, which you can see there.
Hey, Todd, this is Art. Before you move on, I hate to interrupt, but we do have a couple of questions that came in that deal with, you know, this preparation slide. So I think it's timely to take a look at it. The first question is, do you need to mist the milled surface with water before paving the concrete? So once you have it clean, as you're showing, would you recommend misting it with water?
Yes, that's a very good point. We would definitely recommend misting the pavement. What you don't want to do is you don't want to pond water on the pavement, but you do want to cool that surface down. So I'm trying to get back to my presentation. But that's a very good point. We don't usually in the spec for these types of projects, we do have a temperature requirement in there for the asphalt. So we never want to place concrete on something really hot and basically cook the concrete. So we want to get that temperature down. I'm trying to remember what that temp is. I want to say somewhere less than 120 degrees, but usually we want to miss that pavement. Or if you do put water on the pavement, you can go back with an air blast if you do get some puddles and just blow those puddles off. And usually for our environment down here in Kansas, it's pretty hot during construction season. So you want to do that misting fairly, pretty much right before you're going to do the concrete paving. If we do it an hour or two before, it's not going to do you much good because it's going to dry. That pavement's going to dry. It can be basically surface saturated dry is what you want.
Okay.
Was there another question there, Art?
Yeah, and there's one more, and then I'll let you get back to it. So I do apologize.
No problem.
The other question is diamond grinding for ride incentive specs required for all rural concrete road projects? And how soon can grinding be done after you pour an overlay?
Diamond grinding is really a function of the concrete strength. So I think if you talk to our sister association at the International Grinding and Grooving folks, you basically want the full strength of the 28-day full strength of the concrete developed before you do the diamond grinding, which again usually you're hitting that design strength well before 28 days, but a lot of times in the spec it'll say 28 days or the full strength development of the concrete, which for us would be 3,800, 4,000 psi. I will tell you, we constructed some of the longest stretches of 6-inch concrete overlay in the country on I-70 in western Kansas, 6 inches thick, and we got super ride quality on that project without diamond grinding. Mainly, one of the reasons is when you only have a 6-inch head of concrete and you're placing it with a slip form paving spread, you don't end up with that as you're extruding that concrete through the paver. You don't have near that head of concrete basically that's making it kind of hump up behind the screed. So we really got super ride results, paving a mile and a half a day with that paving spread and getting super ride numbers without grinding.
Okay.
If you're in an urban area, I'm going to tell you, and you have a bunch of blockouts, you're doing 1,000 feet here, 1,000 feet there, blocking out for a business. You have other existing pavements and structures you're trying to hit. You might want to put a grind in the contract. So if you're going to build in roughness to the pavement during the process, instead of going back and doing bump grinds and which is great, it gets it back to 100% pay in those areas, but it doesn't look good aesthetically, which is always nice for the pavement to look nice. And you'll notice that when you hit the grind sections, you get a really super smooth ride, and then you get back to 100% pay sections, and it doesn't feel as smooth. So I would always, if you think you're going to have an issue with smoothness or have to do quite a bit of bump grinding, I would just put a grind in the contract. You're going to get a much better price. You're going to get nice, uniform, quiet texture with that diamond grind. I would do it that way.
Okay, sounds good.
You could see on this project, it was just a stretch of pavement between two intersections. So there was really no reason why we shouldn't get a nice smooth pavement here on this project in Salina. It was just a straight shot without much of a problem there. So I know there's no grinds on that project. Good questions. Anything else, or does that cover it for now?
That's it for now, but I will keep you posted as questions come in. So thank you for answering those.
All right, great. And the other thing with diamond grinding, a lot of the expense of diamond grinding is the mob of the equipment. So to get that equipment out on the job site is a large portion of the expense. So while it's out there, if it's, if they're going to be doing some work and touching up the surface, and a lot of times it's almost better just to say, hey, let's just put it in the contract. Grind the pavement when it's done. 100%. Again, nice uniform texture. It's quiet, super smooth. Really makes the project turned out even better when you do it that way. Here you go. In this case, they just use a vibratory screed, working off the existing curb and gutter and the existing pavement, or the first phase of the pavement there. You see the 6 by 6 foot joint spacing there. You just got the longitudinal joint down the middle of the lane at 6 feet. Again, nothing special. Did some night sawing there, and then you see the finished product. I will tell you on the sawing in the urban areas, I don't know about North Dakota, but I know down here in our area, the noise is a big issue. A lot of cities have noise ordinances that we have to work around now, which basically requires us, does not allow us to saw at night anymore in a residential area. So that can create some issues. So we really have to, when we schedule our paving, we have to be aware of, hey, we can't pave after 3, 4, 5 o'clock in the afternoon because we know we're going to be sawing at 10 o'clock or midnight. So be aware of that, or sometimes the cops might show up and shut the sawing contractor or subcontractor down. So, all right, another project application. Here's a parking lot application. This is Twin Chimneys Elementary in Fort Zumwalt School District. It's in St. Louis, Missouri. This is one of our early projects where we did a concrete overlay on the existing school parking lot. We've now done about 30 or 40 of these over in the St. Louis area, and they've really turned out great. And got 3 or 4 school districts that really love these. So if you want more info, we have tons of info on these projects over in the St. Louis area. This project has about 120 spaces. It's got an entrance and a drop-off lane and a bus loop built into the parking lot that I'll show you in a minute. Here, the design, we did 4 inches basically in the parking stall areas, 6 inch in the bus drive areas. So anywhere where the buses were consistently driving, we beef that up to 6 inches thick to address the bus traffic. Again, we use that 3 pounds of microfiber, no steel, 4 to 6 foot joint spacing based on the 2 different thicknesses. Single cut, less than a quarter, no sealant, no joint sealant. Very similar mix of UTW and white topping technology. And basically we characterize this as a BCOA in some areas and an unbonded overlay in others over asphalt, which I'll show you in a minute. So here's a schematic in the concrete overlay guide for unbonded concrete overlays over asphalt. Very similar to the previous one. The only thing you'll notice is it does not require milling. So we're not trying to establish a bond. We don't necessarily need to mill the pavement off unless we're addressing profile grade increase, or there's so much surface distortion in the pavement that if we milled the surface first, we'd end up saving or limiting the volume of concrete we're going to need to fill that area. So sometimes it's less expensive to go out, profile mill the existing pavement so we're not overrunning. I don't like to say overrun because I don't believe it's a overrun really, but we're decreasing the volume of concrete we're going to use out there, which there can be a cost savings in that. So you kind of have to take that into consideration. And then you're placing your overlay just like we talked about before. Here's a bird's eye view of our plan shot of the school and the parking lot area. You can see the red there's where the bus lane or the 6 inch section is going to be. Don't look at those thicknesses on the plan sheet because we actually used 4 and 6 inches. And you see the yellow, the parking stalls, we basically went with a 4 inch thickness. This is a good shot because it really shows you sometimes owners and engineers ask, well, how bad a shape can the asphalt be in? It probably needs to be in good shape, right? Well, in order to do a concrete overlay. And that's not the case in a lot of applications. So you can see here, this existing school district parking lot and entrance roadways, it was pretty badly oxidized. We had some rutting and some, some minor structural issues out by the dumpster. We got potholes and some moisture issues, some block cracking. So it's in pretty rough shape. And really, this pavement wasn't that thick that we were working off. But the one beauty here is we were able to raise the profile grade when we got away from the school building, because we were in a, we didn't have to meet a lot of existing structures or other objects once we got on into the larger parking lot expanse, the parking area. So that helped us with not having to mill down where we didn't have a lot of asphalt to deal with in the first place. So here, this was all hand placed. So the contractor just went out, formed it up, basically all hand placement. You see a few shots there. The upper shots, they're out in the parking lot area. Bottom right, they're actually working on the entrance road. Here's another shot. You can see in this, it's fairly obvious that we didn't mill the existing asphalt out in the parking lot. You see the yellow stripe still for the parking stalls. You'll also notice what I was talking about before with the variable thickness. So you'll see there we had a minimum thickness of 4, but we had, variability in the existing the existing profile. There was some variability in that. It was not a uniform cross section or profile we were working off. So we ended up with some areas of where the overlay was thicker. So of course, in those areas, doesn't matter what we fill them with, we're going to need more material. So sometimes it's kind of a guessing game about how much material are we really going to use out there, because if we base our quantity off our 4.5 inches, and we have some areas out there that are 5 and 6 inches thick, your concrete quantity is going to be a lot higher than everybody originally thought. And that's okay, except usually there's a debate about, well, who's going to pay for that? The contractor wants to get paid for the concrete they used, and the owner says, well, hold on here. We didn't have that built into the contract to pay you for all this additional concrete. So we kind of want to address that up front, either by, most of the time the way we do it now is you really go out and do a pretty detailed survey of the existing pavement, get that all set up, and then calculate, if we set the minimum thickness of the overlay at 4 inches, how much volume of concrete are we going to need to meet our profile, to meet our smoothness, to meet our minimum thickness? And then we go from there. And then sometimes we might say, hey, it'd be better to go out with a milling machine if we have enough asphalt, do a profile mill, and get that surface, that existing profile, a lot closer to the final profile so we can cut down that volume of concrete. So you see there, finished product looked really good. Again, this was June 2008, if I'm reading that correctly. And so this is really a good time to talk about the other item that comes up a lot as it relates to quantity and volume of concrete. So here we have an existing pavement, and the existing pavement has a pretty good uniform profile and smoothness, both cross slope profile and profile down the road. We design our overlay. If they match up perfect, then really if we spec a 4-inch or a 6-inch concrete overlay, we're going to have concrete overruns typical to what we would for new construction. That's great, but that situation doesn't exist very often when we have existing asphalt pavements. So in this situation, everything works out perfect, and you could, and it'd probably work out if you bid this project as concrete by the square yard. So you just said, yeah, the project requires 20,000 yards of concrete. We're just going to bid it 4.5 inches for our volume, and we're just going to put in a bid item for square yards of concrete placed and provided. Just one bid item. That situation doesn't exist very often. So the reality is we have a surface that has a lot of undulations in it. It's not uniform either from cross slope or profile, as asphalt tends to move around. during the course of time. So we're not dealing with a profile that's close to our final profile. So when we drop that concrete overlay on there, you can see there's going to be some areas that we're going to have to fill in with concrete to address the profile to meet our minimum thickness, our smoothness, our cross slope, and our final elevations. So that volume is the volume no matter what you fill it with, which is the reason I don't like to call it overrun. It's just the amount of material it takes to get you your final product and those minimums that you want in terms of thickness, cross slope, and smoothness. So in this situation, what we'd really like to see owners do, and it really takes a lot of the risk out of the jobs for both parties, the owner and the contractors, is bid the overlay with 2 bid items, one for placement of the concrete, so the actual physical placement or the construction of the overlay, square yards, and then pay for the volume of concrete on a cubic yard basis. And this really is the safest and least risk for both parties. So you're building the placement by the square yard and the material by the cubic yard. And that works really well for these situations. And then you don't get into those arguments at the end about, hey, you know, we used 25% more concrete, which can happen. That's a realistic number than we thought. Just basically addressing the challenges and the issues with the existing profile. So here, profile grade increase, how did we handle that up against the school? You can see there in the upper, the right side of the screen, what we did is we basically, because this pavement was in pretty tough shape and it wasn't that thick to start with, we really didn't want to start milling in there 2, 3, 4 inches and have the milling machine start to break through the existing asphalt, because then we have to address those areas in some fashion. It slows us down, it's more costly. So in this case, we basically just raised the profile, as you can see there, and we raised it up so it was flush with the sidewalk and the walkways there, and that worked out really well when we got up against the school. And there's the completed paving. Again, turned out really nice. This project's 12 years old now. Performing fantastic. You got the nice light bright surface, for the lighting and the safety out there for the students and the staff. It's nice and cool surface as well. We've actually recently done some playgrounds, and that was a big benefit, with the children playing out on the concrete overlay surface. It was a lot cooler during the summer months. So that was great. So these were applications where there was no traffic on them at all other than foot traffic. And then here, if there's no questions, Art, the last project, and this one is kind of something a little different, but it kind of shows you what you can do if you think a little bit outside the box, and basically say, hey, we're going to go into this project with the mindset of coming up or constructing a concrete overlay for this application. And this is an intersection project in Salina, Kansas again. The existing pavement was kind of a hodgepodge of full depth asphalt and composite pavement. And this is probably what you'll find in a lot of cities, is older cities, is the existing pavement is all sorts of things. It's got utility patches in it with concrete. It might have some old brick in there if they're really old streets. So you never know what you're going to find out there. And we'll talk about it in a minute, which is why you always want to go out there and do a fair amount of coring to make sure you understand when you go into the design and the construction that you know what you're going to run into once you get into the job. So for this project, it's really high traffic. I'll show you in a minute. The city really wanted a long-term product out here. They knew this was going to be a little bit of an inconvenience. So they wanted this concrete overlay to, give them 30, 40 years of performance. So we decided on an 8-inch concrete overlay, dowel reinforced there, the non-reinforced dowel jointed, 12 by 12 foot joint spacing or panels, 11 foot in some areas because of the roadway width. In this application, we did a double cut on the joints, 3/8 inch wide, and sealed the joints. It was constructed in 2012 by Pavers Inc. again, our contractor out of Salina. And this is a mix of white topping and unbonded overlay technology over concrete. And we also incorporated the geotextile inner layer for the unbonded portion. So this was a cool project. The other thing you want to notice about this project is we mixed and matched overlay technology. So it's not a problem. Again, if we know what's out there and we know what we're going to run into once we start milling or getting into the existing pavement, we can come up with all innovative overlay designs for the different situations. So that's not a problem. Again, really cool, interesting project. So here's the schematic for the unbonded concrete overlay over concrete. You see there we got the asphalt separation layer that historically or typically we'd use between the existing concrete and the new concrete overlay. In this application, instead of bringing in an asphalt operation to place that 1 inch of asphalt to separate the existing pavement from the new pavement, we use the geotextile paving interlayer fabric that I'll show you in a minute. Purpose and need, I'll give the HWS or my friends at Benish Engineering credit for this. This was out of their presentation that they gave at one of my events down here about how they came up with this design. So the purpose and need, the pavement was in really rough shape from a condition standpoint. It needed some type of rehabilitation. Very high volume intersection, probably the highest in Salina at 35,000 vehicles a day. They were having a lot of recurring maintenance, which is why they wanted to, which was the purpose of the project. One of the goals was to eliminate that and reduce that maintenance. And they needed it for a detour for another project in 2012. So they wanted to get this job done because they wanted to use the part of the detour for another project would be using this intersection. So we had two major arterial streets. We had Ohio Street, one of the big arterial streets in Salina. You can see it ranged from 11 to 15 inches of asphalt, full depth. And then we had Crawford Street, which is another arterial that comes off of I-135, which is one of the other projects that we were detouring, that we were doing work on, so that the detour traffic from the I-135 project was going to be using this interchange. And that ranged from 1 3/4 inches of asphalt over 7.5 inches of concrete to basically the 7 1/4 inches of concrete with thicker asphalt sections on it. So it was, again, it was really a hodgepodge of existing pavement out there. They kind of came up with a pros and cons just list here for looking at a hot mix asphalt overlay versus a concrete overlay. So you see the pros for asphalt. These are nothing that you probably wouldn't normally think of, right? Asphalt overlay, right? We're in and out of there quick. Doesn't take a lot of design effort. Maybe a less of initial cost. That's not always the case. Construction schedule might be quicker and construction sequencing might be easier for us. The cons with the asphalt, of course, higher long-term costs. So they expected to do more frequent maintenance if they went back with asphalt. They thought they'd be back within 4 to 7 years. So that was a con, you know, after inconveniencing the public. They didn't, and the businesses, they didn't really want to show back up there in as short as 4 years doing maintenance work again. And so it really didn't meet the project goals, which then kicked us over to the concrete overlay side. So the pros, a little longer, but you know, basically it's the get in, get out, stay out motto was the pro for the concrete overlay. Lower long-term costs. So we had the expectations of once we got this built with concrete, we were going to have much lower maintenance and less frequent maintenance out there. It allowed for future widening of the project. Construction schedule, as we'll show you the phasing in a minute. Construction sequencing. So even with concrete, we can do these projects really fast and on a short time schedule. Sequencing can be handled, as I'll show, and maintenance of traffic, as I'll show you in a minute. Again, we're going to stay out. We won't be back for a while. And so the concrete really met all the project goals that were set out by the owner to the engineer. The cons, a little more design effort, as I already showed you. You know, we had some existing conditions that we needed to deal with in different ways, and the construction limits. Certainly, a 2 or 3 inch asphalt overlay is going to be a heck of a lot cheaper first cost than an 8-inch doweled concrete overlay. So essentially, what they did is they shortened up the construction limits of the project and really did the 8-inch overlay where they knew they needed it and to hit the business entrances they wanted to hit, and then they just overlaid, put a thin overlay on the sections outside of that. Design concerns, we wanted a smooth ride, as somebody mentioned. We did not want to raise the grade, so we wanted to be able to keep that profile and hit all those existing structures and other pavements and entrances and existing pavement that we needed to hit. We wanted to maintain the drainage. We wanted to make sure we didn't punch through the existing pavement, meaning once we milled that pavement down, we didn't want the milling machine punching through. And that question always comes up. Well, how thick does the existing asphalt need to be or pavement need to be for us to use it to construct an overlay on? And how much can I mill down? Well, basically what you want to do is you don't want to mill a pavement to the point where the milling machine's falling through the existing pavement. Because what that's going to do, it's going to slow you down. It's going to require you to do a bunch of repairs out there and address those situations. And it really takes away the cost savings and the expedient nature of these projects. So that's really the standard we use. If you can keep the milling machine from falling through, then that's really why you want to limit that depth of milling for the concrete overlay. How to handle punch throughs? Hey, if milling machine does punch through the existing asphalt, we want the contractor to know at that time what they need to do. We don't want to have to stop the project, call somebody, get some folks to come out to the job, say, hey, this is what we have. What do you think we should do? We want to have all that lined up in the project plans and specs. So when we do hit that situation, everybody knows what they need to do and it's all laid out and we can just keep on going. Maintenance of traffic, that was a big one on this job with 35,000 vehicles a day. Balancing project limits with construction duration. There are businesses around this intersection, so we had to worry about business access. Contingency plan, we just talked about that. And you can never have enough cores, so you need to go out there. What you don't want to do on these overlay projects is just take the existing plans off the shelf and say, hey, the existing plans show this much asphalt, this much concrete. We kind of did these actions over time. That's what's out there. You will get burned if you do that. I guarantee it. So you always want to go out there and take as many cores, and really you can't take enough to make sure you identify what the existing pavement is out that you're dealing with and how thick those layers are. Because I think you'll be surprised, especially with asphalt pavements, the variability in thickness throughout the asphalt pavement sections, because they can vary by 2, 3, 4 inches sometimes over the same project. And as you can see here, the city was really freaked out about this project. People thought it couldn't be done, thought the city, the engineers, and our industry was crazy. The paper had Carmageddon in there. It was going to shut the whole city down. You know, get prepared. Again, we're talking about Salina, Kansas, not LA or New York, but people still freak out even in small towns about inconvenience or doing road construction. So that was the headline we were dealing with. We kind of convinced the owner and the engineering firm, hey, we got it. Just tell us what you want. Tell us the schedule we need to meet, the times we need to meet, the traffic delays and road closures you can live with, and we'll take it from there. Here's the typical sections for the street. Here's Ohio Street. You'll notice there we got the 8-inch dowel jointed pavement after we profile milled. And then we have the geotextile fabric. So in this area in Ohio, once we milled down, we were into existing concrete. So now we're placing this concrete overlay on existing concrete an existing concrete surface. So we need that separation layer in there, that geotextile separator interlayer in there to separate the new pavement from the old pavement, so we don't get any reflective cracks coming up or joints coming up through the existing pavement into the new overlay. Crawford Street now, this was full depth asphalt, right? So here we got our 8-inch pavement. And here, what we thought, hey, there might be some areas here in this existing asphalt section where the milling machine's going to punch through. If that happens, what we're going to do is we're going to hog that existing asphalt out. We're going to regrade it. We're going to throw out 9 inches of aggregate base with geogrid to address these sections. And we're going to, we're going to go down the road. We're going to quickly install that, and then we're going to place the 8 inches of concrete over that. So that was our contingency for that. There you see the geogrid. So it was kind of a mix and match of overlay technologies again. Here's the construction sequencing, pretty standard quadrant type construction sequencing. We're doing it in 4 phases, each quadrant at a time. Traffic was reduced to 1 lane. So we're talking maintenance of traffic. We reduced traffic to 1 lane in each directions. No left turns allowed at the signals or entrances in the work zone. 20-mile-an-hour speed limit. Actually had the police force out there monitoring the project. And you can take this one for a plus or a minus, depending who you are. But they wrote over 500 traffic tickets during the course of this project. So I'm sure that upset the folks that got the 500 tickets, but that probably brought in quite a bit of income to the city in violations and fines paid. So, so even with the 20-mile-an-hour work zone and the cops out there, they still wrote 500 tickets. So original contract was roughly $427,000, about 3,200 square yards of concrete, 400 tons of asphalt, which was the asphalt overlays they did outside the overlay section, tying back into the existing streets. Replace the curb and gutter sidewalk, sidewalk ramps, inlet tops on all 4 corners of the intersection. And then also that cost included the base repair that we talked about with the 9 inches of aggregate and geogrid that we had specified if we ran into those situations where it was needed. So basically for that, you can just put in a unit price for these things, since you really don't know how much they're going to be or when you're going to run into them. So you already have a agreed upon price. So we're not haggling over that, when the situation arises, but it's already in the contract. So if we run into that, we know, hey, if we're doing this many squares, or that we need this many tons of rock and this many square feet of geogrid, this is what the cost is going to be. And this is going to be the cost of placement. Here's the milling construction. Just real quick, you can see there's some base work. So we ran into a spot where we kind of had a soft spot out there. Here's the area where when we milled down, we exposed the existing concrete. So we placed that geotextile interlayer down. You just roll that stuff out, nail it down on about a 6-foot grid with concrete nails and washers there to keep that fabric down so it doesn't blow. Again, this fabric's black, so summertime placement, you want to cool that fabric down. So you always want to wet this black fabric down. There's also a white version where that's not needed, but the black version, certainly it absorbs heat. So we're going to want to wet that inner layer down beforehand, so we cool it down before we place the concrete. There's our dowels and tie bars being staked down. Concrete placement. Nothing special there. And then we double cut these joints and sealed them with a hot pour. Nothing fancy. Here's a situation where we ran into an issue where we had some concrete that was in bad shape that we needed to repair. Soft spot, either could have been a utility patch. You never know under there that was done over the years. So we want to make sure we have contingencies in the plans and the specs to address these situations. Don't fear the unknown, right? Be prepared for it. So there's that soft area I showed you before. We just hogged that out with the milling machine a little deeper and threw in some compacted some millings in there to address that situation. Remembering once you get the 8 inches of concrete on that, there's no concern there. So the biggest thing with these soft spots and these distressed areas was, can they handle construction traffic? When we back that concrete truck down the grade, is it going to be punching through and distorting the base? We didn't want that to happen. So in a lot of cases, the existing pavement needs to be able to support the construction traffic. And it's the reason for the repairs is not necessarily for the concrete overlay performance itself. Here's that rock going down, that aggregate material with the geogrid for those situations where we needed it. There's kind of the finished sections. Again, we're staking down the baskets and the tie bars, forming the, putting the place, basically staking down the place in the concrete forms. Here's an area where they found basically a void under the pavement. So either we had an old, a water leak or a water main break, or for some reason we ended up with a big void underneath the pavement where you could kind of crawl down in. Basically, the repair for this is we filled it with like a fly ash slurry grout is what we did there. Kind of a, what would you call it, flowable fill type application. Had that set up, and then we could go on with the 8-inch concrete overlay. Constructing the pavement, again, vibratory screed there on the forms. And basically, we went from this, the existing pavement, existing project or roadway, to this. It turned out really nice. It was open to traffic in 45 days. So despite the prognostication of Carmageddon, which didn't happen, we got the project open in 45 days. Basically got a 30 or 40-year product out there that the city won't have to deal with. People won't have to be inconvenienced. You can see there we got a, what's that, one of those fish places, an A&W there on the corner. So we have some businesses that are not going to be inconvenienced again for a long period of time. Hopefully people by then will forget we were ever out there, and I'll be looking forward to the next project 30, 40, 50 years down the road. So just to sum it up, things, urban overlay success, what are the keys? Know what you're working with. We talked about it. We really need to know the existing pavement type and thickness. We need that for the design, but really important once we get into the construction to make sure we have contingencies, a contingency plan for situations that may arise if we get into some different pavement thicknesses, some different pavement materials. Again, you can't take enough cores, get your geotech folks out there, take some cores, know what you're getting into, know what you're dealing with. From that, select the appropriate overlay type. Again, we talked about the thinner ones, 4 and 5 inch bonded. We also talked about on the last project an 8-inch unbonded. I don't think most people would think you could do an 8-inch unbonded in the middle of a city on some urban arterials, but if you have enough pavement there and you come up with a good design and plan, you can do it. What's the surface prep going to be for the bonded versus the unbonded? What's the thickness of those overlays? How much profile and elevation increase can we live with? How much existing pavement can we mill off? And we kind of work our thickness from there. How long do we want the overlay to last? Typically a 5 or 6 inch overlay will probably get you 20, 25 years pretty easy anymore. We got 6 inches out on the I-70. It's already 10 years old. It's a 20-year design. It looks like it's easily going to make it. So 6 inches of concrete over existing asphalt or existing concrete last a long time, carry a lot of traffic. Joint spacing, what's our overlay thickness? What's our overlay design? What are we putting on? Come up with our joint spacing. Again, establish a plan for base or subgrade issues that may arise. Be prepared. Have a bid item for those things so we're not arguing or haggling about them during the project or after the project. Develop a construction phasing plan to minimize disruption and maximize productivity. knowing that the contractor may come up with something more innovative, the low bid contractor that gets the award of the job. So have some ideas or have some stipulations that the contractor has to meet, give them to them, and if they can come up with a more quick and easy way to construct the pavement in a better fashion with less inconvenience to the public and the businesses, why not let them come up with some innovative solutions that meet your criteria? And always remember, sometimes it's better just to close the road. Maybe get the job done in half the time or a third of the time. Yes, the road was closed, but you get it done a lot quicker, may save you quite a bit of money on the project. And you tend to maybe end up with sometimes a better product and a better project if you just close the road and knock it out without having to deal with construction and maintenance of traffic during the construction. Again, establish a reasonable pavement opening strength based on design and traffic. I think we're finding as an industry and a lot of our agencies are coming to the conclusion that we can open traffic or open pavements to traffic a lot quicker than we ever thought. I can tell you in Georgia, they open up their interstate pavements at 1,200 PSI to 200,000 vehicles a day on the interstates around Atlanta. So 1,800, 2,000, certainly 2,500, you can open these pavements up, especially to lighter car type traffic where you don't have a lot of trucks. And use maturity. These jobs are great for maturity. I think you're crazy if you're not using maturity on a project as a contractor where you're dealing with maintenance of traffic in an urban setting with businesses. It's a lot easier. You can turn construction around a lot quicker, open pavements a lot quicker. It's really a great way to go. Establish those appropriate bid items, right, for the repairs or the situations that may arise. And also make sure you're addressing the square yard, cubic yard placement. So if you know it's going to be difficult to ascertain what volume of concrete we're going to need based on the existing existing pavement condition and profile and cross slope, use the square yard, cubic yard method to bid the project. It's going to take the risk out of it. You're going to get lower bids. It's going to be a lot better than if you do happen to use 25% or over on the concrete 25%. You're going to have a debate about, hey, the contractor wants to get paid for that, and the owner's going to say, well, I wasn't prepared for 25% more concrete being used on the job. So go out, survey the project while you're coring it, know what you're dealing with in terms of existing elevations and profile. Develop and design the project from a plan and spec standpoint, not with the conventional reconstruction approach. View it and develop the project and a design and construction with a rapid or fast track mindset, right? The benefit of doing a concrete overlay is it's quicker, it's less expensive, it's less inconvenience, and go into it with that mindset that, hey, to satisfy this or get the most benefit out of doing the overlay, we really need to treat these projects in a different manner, in a more rapid, fast track manner, fast track, rapid set mindset. So go into that way, think outside the box, right? Don't be afraid to give your contractor, your industry leeway or the opportunity to innovate. A lot of times they can come up with better ways. I get some contractors, like I'm sure Art does up your way, that are pretty innovative thinkers that come up with some pretty neat, expedient, cost-efficient ways to manage and construct projects that on the design side or as an industry person, we often, we don't think of these things, but them being out in the field all the time, they can come up with some great innovations, time savings and money savings. And, despite what our industry would like to do and say, hey, concrete overlays are no different than asphalt overlays, they are. It takes a little more thought to come up with a good concrete overlay design and spec. These things need to be engineered As an engineer, I find it pretty refreshing to go out there and, hey, give me an existing situation, existing application. I guarantee you we can come up with a concrete overlay design or engineer a concrete overlay solution. May not be the cheapest. It may not even compete, but we can certainly throw out an alternate or solution that can be considered. A lot of situations that can compete, but I don't think there's a situation out there that we can't really come up with a concrete overlay design or solution to at least be considered. Software tools, I mean, Eric talked about pavement designers, but there's all sorts of different overlay tools available to you for designing concrete overlays, depending on what type of overlay it is. Again, everything from highway overlays with the AASHTO Pavement ME product, down to the pavement designer, city streets, parking lots, you name it. BCOA, we have a mechanistic empirical design procedure for BCOAs. Colorado has an overlay design procedure for 6-inch overlays that they use, just a spreadsheet. All sorts of different tools out there for you. You can go to the ACPA website, of course, and get a lot of those out of their app library, acpa.org/applications library. Again, just remember, family of concrete overlays. Really, we only have 2 types anymore: bonded overlay systems and unbonded. It doesn't really matter what's underneath. We can come up with a design or a engineered concrete solution. Available resources: acpa.org, cptechcenter.org. You can download that overlay guide and all their great resources. Portland Cement Association, cement.org. There's my email address, or Art can get a hold of me. And there's our website. And with that, I'll, with football season and with us trying to run it back this year, that's the slogan. Are there any other questions, Art?
Yeah, we just had one, Todd. What are you seeing in construction activity in terms of price between, concrete and asphalt in your market when you're allowed to do alternate bids? Are you winning concrete projects, on the first cost, or are you looking at life cycle, or, what is the fluctuation between concrete and asphalt pricing in your area?
Very good question, and thanks for asking. So it kind of varies. I mean, Kansas and Missouri, like North Dakota, are pretty big states, so it kind of depends where you are. I will tell you, in Missouri, Missouri DOT bids every project they put out of any substance as alternate bids. So we've had 200 or 300 alternate bid projects over the last 15, 18 years. So every job that goes out of any substantial thickness, it has an asphalt option and a concrete option. It does include a life cycle cost depending on the size of the job. And I will tell you, concrete wins about 75 to 80% of the time. And there's only been 5 jobs ever where the life cycle cost, so out of that 200 jobs, only 5 have been decided because of the life cycle cost adjustment. So most of the time when concrete wins, it wins on first cost, whether it's reconstruction or a concrete overlay. So that's in Missouri. So we compete really well. Kansas, probably not as much. I would say there are jobs where we do compete on first cost, and there's jobs where it does take the life cycle in some cases, and there are jobs we don't win. I mean, one of the things you got to remember is we're not asking anybody to, if we put out a concrete overlay, we're not assuming it's going to win every time. But we think in a lot of cases, in a lot of situations, our products will compete really well. If nothing else, it'll probably get you a lower overall project cost, even if it does go asphalt. But it really just depends. So if you go out into western Kansas where materials are scarce and everything's got to be hauled a long way, certainly the prices are a lot higher. Again, urban projects, it depends too. It really matters if it's a really chopped up job and you can only do short runs of concrete. Certainly the price goes up. If we can do more high production, concrete is much more competitive. If we can do monolithic curb and gutter on jobs, which we do on some projects, we're a lot more competitive. So it really depends. But I don't think you should just go into these projects thinking, well, concrete can't compete. If nothing else, I think it's worth it, and you're probably going to save money in the end if you throw out that concrete alternative or opportunity or solution and allow the contracting industry to bid it. If it goes concrete, great. Art and I are really happy. If it doesn't, hey, we appreciate you giving us a shot. Maybe there's things we can change on the job that would make us more competitive going forward. But I'll bet you get a lower asphalt price, because we see that all the time. MoDOT actually tracks that, Missouri DOT, and they say, you know, they're getting 5% lower prices when on these alternate bid jobs versus straight one pavement projects, basically, where they're just specifying one pavement. So I hope that answers your question. We use life cycle a lot, especially on the DOT side. I know life cycle cost adjustments are hard sometimes on the municipal side because they really don't have the it's tough to go to a commission and say, hey, you know, for 10% more we can do concrete. Sometimes it's tough for commissions that aren't going to be on the boards and the commissions for a long time to accept that. We have some cities that just say, hey, if the concrete bid's within 10%, we're going to go with the concrete up front. What you want to do and what makes everybody happy and alleviates a lot of arguments is put it in the specs and the contract documents how you're going to make a decision. So if you're going to have a life cycle cost adjustment, put it in the contract documents. If you're going to make a decision based on, hey, if it's 10% higher the concrete, we're going to go with concrete. And at least people know going in, and nobody thinks you're trying to pull a fast one after the fact. That makes it easier for everybody to swallow. So it just really depends. We love a life cycle cost adjustment on all these jobs, but hey, we know that's not always the case. So
certainly. And with that, Todd, we did run a little bit long, so I do appreciate the audience sticking with us here today. I think we've had a tremendous afternoon. I want to thank Todd. I want to thank Brian. I want to thank Eric for sharing their knowledge with us. Really great afternoon talking about concrete. We have another day in store tomorrow, kicking off again at 1 o'clock, where we're going to look at more of economically efficient ways to manage pavement networks, and then also the future of highways, and then concluding with our 2020 Gold Star Awards Excellence in Concrete program. Couple of other announcements. We did cover a lot of area today. We do have the emphasis of education for our association. So we do have 4 pages of continuing education opportunities coming up in our, in 2021. You can find that in our January 21 e-newsletter that's out on our website. If you want to get more alerts from us, go ahead and contact Savannah Schmidt, get on our e-blast list. Would suggest that you follow us on our Facebook and Twitter accounts. Look up North Dakota Concrete Council for Facebook, Concrete ND for Twitter, and then again, check out our website, ndconcrete.com. In conclusion, we want to again recognize today's sponsors, our platinum level sponsors for the convention. Certainly couldn't do it without you. Same thing with our gold level sponsors. Certainly appreciate your support in allowing us to fund programming like this one. Getting great speakers from across the country to impart their knowledge with our concrete industry partners is a great thing. In-kind donations, once again, thank you to them, as well as the broadcast team with North Dakota LTAP. I am extremely proud, and I don't believe from my perspective that we saw any glitches today, and that's always a worry with these virtual events. Hopefully it was smooth for you on the other end as it was for us in presenting the information, and that goes a long way to what Dustin and Dale and the group at LTAP did to get us prepared for today. So thank you to them. And then thank you to our prize drawing donation gift givers. Certainly couldn't do it without you with that. So Again, I apologize that we ran a little long, but I think we had great discussion, great Q&A. Thank you for being here. We will see you back on the virtual ceremony and training tomorrow at 1 o'clock. Thanks for being here.